Hey, did you leave the tab open? Did you leave the tab open? You're probably wondering where this noise is coming from. Yeah, now it's weird. You can't find the tab. You can't find it. Oh, wait, you found it. Hey, no, nothing to see here. Just us streamers. Mr. Streamer Man. Oh, okay. Hi. Good morning. Hello. Close out all the rug shopping tabs. Jim, I don't got no shopping tabs open. Certainly came for any rugs. That's for sure. The third fresh pot that the garage has produced. Garage fresh. Very nice. Anyway, we got a NASA press conference happening here. It is a Artemis 1 launch update, so we're going to hear what's going on with the bleeps, the sweeps, and the creeps. And also, we got static fire stuff for Starship, supposedly. Yeah. Oh. Here we go. Here we go. That was a banana. It's the chromana. Still don't understand why this is chroming, because that's definitely not green.
Discovery, go at throttle up.
How's that go? 14-month resub. Thank you, buddy. Green banana. Hand banana. So, actually, just on a side note, guys, we are going to conduct a little thermodynamics experiment today. You can share my progress pictures. Do what you want. Oh, okay. I need to. So here's what we're gonna do. It is currently time to wake up. It's 68 degrees in here. It's 20 C right on the dot. So what I'm doing here is I want to test the insulative properties of the drop ceiling. No air conditioner. No air conditioner on, and it's about 70 degrees out, so it's about 20 outside. It's nice. It's nice out, actually. The sun's out. So what I'm going to do is we're going to play games. And I'm just going to see how much heat the computers generate here, and I want to see if that heat stays in here.
You may press star 1 on your phone to ask a question.
Yeah, Raj,
I would like to inform
humidity.
all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Catherine Hambleton. Thank you. You may begin.
In the meantime, I'm going to shut up here.
I'm Catherine Hambleton with NASA's Office of Communications. After standing down on the September 3rd Artemis 1 launch attempt due to a leak in one of the fuel lines, teams have decided to replace the seal on an interface called the quick disconnect between the liquid hydrogen fuel line on the mobile launcher and the rocket while at the launch pad. Artemis 1 is a flight test to launch NASA's Space Launch System rocket and send an uncrewed Orion spacecraft around the moon and thoroughly test the spacecraft systems before missions with crew. Here to talk with us about the path forward are Jim Free, Associate Administrator for the Exploration Systems Development Mission Directorate at NASA headquarters, Mike Bolger, Exploration Ground Systems Program Manager at Kennedy, and John Blevins, SLS Chief Engineer at NASA's Marshall Space Flight Center. We'll have a few opening comments from each of our speakers, and then we'll take questions from reporters on the phone. Reporters can enter star 1 on your phone to be entered into the queue at any time. First, we'll hear from Jim Free. Jim.
Yeah, thanks, Catherine. Good morning, everybody. Thanks for making the time to listen and stay interested in where we're headed with Artemis 1. I had two things I wanted to talk this morning. The first is I brought up after on the news conference what we're trying to do with the range and our FTS batteries and the retest requirements that the range has for us. Well, I think there are some things that I probably didn't state clearly enough in the first one. I want to make sure everybody knows that the range has been a great partner in this for us. When we talked after our attempt on Saturday, we were just kind of in the formulation stages of what our plans were. And General Purdy and his team have just been fantastic at listening to where we want to go and giving us their thoughts and us making sure we understand their requirements and concerns. We did submit our waiver package to them to get our retest requirement out there. After meeting with them several times, again, they've been very gracious and understanding of what we're trying to do. I'll reiterate to the fact that our job is to live to their requirements. It is their range, and it's our job to comply with their requirements. So we will do that. Having said that, we're trying to plan a path forward if we're allowed to extend our battery retest requirements on the flight termination system. So to that end, we've asked for a couple dates on the range to support our planning. You'll hear about the tanking test in a few minutes from John Blevins and Mike Bolger. But our requested dates we put on yesterday were the 23rd of September and the 27th of September. Those dates I mentioned on Saturday that we're trying to work with other NASA programs and obviously other users on the range as well. The 23rd we picked, we're trying to deconflict with the DART impact. The conflict there is use of the Deep Space Network. We want to stay outside of their, I'll say, lockdown of the DSN, which is why we picked the 23rd, so that some of our critical events, if we were fortunate enough to get the waiver from the range and to actually launch on the 23rd, our critical requirements post-initial launch would fall on the other side of the impact of DART on the 26th. So that's how we came up with the 23rd. And then the 27th of September keeps us on the right side of DART, or on the back side of DART, I should say, and then in advance of some other activities on the range that are scheduled for the 30th. There's actually no conflict with anything on the 27th. And then we're looking at a third date, but that is a constraint with Crew 5. I mentioned that briefly. We're just trying to work with the Crew 5 program, and obviously Kennedy from a consumables perspective with other activities on the range with replenishment times for the GN2 between launches. So we'll hold to those two dates. We'll continue to work with our great partner in the range as they evaluate the realism and feasibility of our waiver request. And certainly if they decide that is not the right thing to do, we obviously will support that and stand down and look for our next launch attempt. But we still will press with the tanking test. So let me turn it over to Mike Bolger and let him talk about the processing going on at the pad and those next steps.
Hey, thank you, Jim, and hello, everybody. Yeah, so I wanted to give you a quick update on how things are going. So since standing down from last Saturday's launch attempt, we've been busy deconfiguring from launch and then working to repair the hydrogen leak that we found during tanking. The repair is basically to remove and replace seals on the 8-inch fill and drain quick disconnect, and then also the 4-inch bleed QD that are both at that flight-to-ground interface between the LH2 tail surface mast umbilical, or TSMU, and the core stage. So to perform that work, we have to demate the LH2 TSMU plate from the flight plate. So there are two plates there that come together, one on the flight side and one on the ground side, to gain access to the QDs Once the plates are disconnected, the workers install transportation caps in the various lines and a plate cover to protect against contamination while we do the work. We're making great progress. Yesterday we completed the plate demate and began inspection of the seals. Following that, we set up an enclosure around the area to protect the hardware from weather and any other environmental conditions while we perform the seal R&R. Regarding the closure, kind of imagine a plastic tent, if you will, that encloses both the workers and the flight plate on some TSMU access stands that we've got out there. So, again, kind of imagine a plastic tent, and we've got some conditioned air going in there as well to keep the environment good for the work that we're doing. This morning, we began the R&R. So we've actually got help from our Boeing teammates out there to do that R&R. And if the weather holds up, our plan is to complete both the 8-inch and the 4-inch seal R&Rs by the end of today. Weather could be dicey later in the day, so if that happens, we might just get the 8-inch done. That's something that we'll be keeping a close eye on. If we're able to get both done today, then tomorrow we'll remate the plates ahead of retest this weekend. The retest will be kind of like a mini IVT where we'll be making sure that the data's flowing and that all of our systems are coming up as expected. Following that, we're looking at a cryo demo for verification of the seal. We set a target date of September 17th. Our timeline to get to that is pretty close, so it could, I would not be surprised to see it slip a day or two, but we're targeting September 17th. And that cryo event will be to verify the seal R&R is good. Our preliminary plan is to have the cryo team tank both the core stage and the upper stage with LH2 and LO2. We're taking a look at our procedures and our software now to think about what exactly that would look like. That could ultimately end up being the long pole to get into the test. One thing that we've talked about with the SLS team, really they brought it forward, is a change in our concept of operations to reduce the pressure and flow changes during tanking. So we're calling it a kinder and gentler approach to tanking. We think that may help reduce the stress of pulses or sudden changes on the seals. So big picture, by replacing the seals and going through this cryo event, making the tanking process as benign as possible, we're optimistic that we can knock this problem flat and have a successful tanking. Let's see, from there, we'll determine whether we stay at the pad for a launch attempt in launch period 26 or whether we roll back. I would tell you the team is making great progress. Morale is good. Still excited for this opportunity that we've got. As always, we'll launch when we're ready. You know, we've talked with our team last week. Wasn't our week, but we know our day is coming, and we're excited about it. So with that, I'll close my opening remarks and pass it over to John Blevins.
Hey, good morning, everybody. Good to be with you again. Like to see the progress that Mike's talking about. It's just great out there at the pad. Let me tell you, from an SLS perspective, we continue to look at life-limited items. We've got a list. We look at that very detailed. We performed high-resolution visual inspections of the vehicle as well as walk-downs, and so we're working hand-in-hand with our partners at the ground systems. The state of the vehicle looks good for our next launch attempt, and so we're ready to go. Really encouraged by the fact that it's been less than 1 week since we've had the one scrub that was due to the leak, and it looks like we've got a good plan going forward, as Mike talked about, with the changes in process and everything. I will just add, when you've got two new systems combined like this really isn't out of maybe the norm of expectation in engineering to work those issues, and so I feel really encouraged about where we're at with the vehicle, and we've been able to turn around this one leak issue within a week with a good plan.
Thanks. And so now we'll take questions from those on the line. Those on the phone should press *1 to be entered into the queue. You can press *2 if you would like to be removed from your queue if your question is answered.
Okay, here we go.
And again, please state your name and affiliation and to whom you're addressing your question. And of course, we do ask that you limit your questions to one question, and so that we can get to as many reporters as possible. And if we have time, we'll go for a second round of questions. So for the first question, we'll go to Marcia Dunn with Associated Press.
For Mr. Free, when do you expect to hear from the range regarding the waiver, and when do you need to hear from them in order to make late September? And it almost sounds like you're in a hurry to get this going. Why not just wait till October? What are the pros and cons about that? Thanks.
I can answer
Thanks,
this.
Marcia.
They don't want to roll back.
We, as I said, kind of at the end of my remarks, we're pressing for the tanking test. That's in our I guess the forefront for us. We're continuing to look for if the range has questions. Obviously, we'd like to hear from them, but we're following their process. So right now, we submitted the waiver, and we'll look to hear from them on any clarifications that they need from us. When we get closer to the tanking test, obviously we'll have to make a decision after that if we don't have a decision from the range. And then the third part of your question was why not just wait and go to the pros and cons about just waiting and going to October. We need to get the tanking test done, and then we'll have to look at what is the realism and schedule for us for launch periods 27 and 28 based on what we learned from the tanking test and what the team would need to do to roll back if we haven't gotten that waiver from the range, and look at the impacts for 27 and 28.
Thank you. Our next question is from Bill Harwood of CBS News.
Hey, thanks. Bill Harwood here. I'm looking for a little detail on two topics. First, for John Blevins, where are the FTS batteries in question located in the rocket? Are they on one or both stages? And what's involved in testing or recertifying them if you have to? And I'm just wondering what data is available to base an extension on. And a quick follow, if I can. I'm sorry, Catherine. Can you give us an update on where we stand on the SRBs in terms of how long they can be stacked before you guys would have to take some action, and what the issues are there? Thanks.
Yeah, the flight termination system's on the raceway on the SRBs, I'm pretty damn sure.
Hey, Bill, this is John Blevins. I might have all three of your questions out of the one question. First of all, there are FTS batteries that are on each system. So we do have FTS batteries that are on the ICPS. There are FTS batteries on the core stage. There are FTS batteries on the booster. The real heart of the system is the core stage. And so the batteries at question that we're talking about are core stage batteries. They are different than the other systems, and because of their size and mass, they're a little more prone to meeting that retest evaluation due to crystal growth. And so ultimately, the batteries that you're really asking about, Bill, are core stage batteries. And so there are three. There's one for every command receiver decoder where you might receive a termination command from the ground and have that set up. And so those actually are kind of the heart of the overall system. And so those are the batteries at question to answer that question there in the core stage. As far as recertify them, I'm really not sure what you're asking, other than we do tests and then we have battery replacement intervals for those tests. But what we do in conjunction with the range or with our partners there is we do end-to-end testing, right? All the components, top to bottom, to verify things. We do also monitor all of the systems while it's on the pad. So there's some monitoring that occurs passively while we're setting out the pad as well. As far as your question on the SRB stack life, we have for a long time, of course, worked with this material, and so there's numerous data that we can use to bring forward to show the risk, which is minimal, with additional stack life based on slump and other properties of the SRBs. And so we continue to do that to show the risk to the decision makers. That risk is very low, and so that's where we are with the SRB stack life. I think I caught all three of your questions, Bill.
Thanks, John.
Be like John.
Our next question
Be
is
like
from
John.
Kristen Fisher of CNN.
Hi, thank you all for taking my question. My question is about something that Mike Serafin said at the Saturday briefing after the second scrub. He described that inadvertent pressurization of the hydrogen line, and he mentioned at the time that he wasn't sure if that's what caused the hydrogen leak or not. Can you all explain now, do you know if that inadvertent pressurization, did that cause the hydrogen leak on Saturday? And if so, Was that human error or computer error? Thank you.
That's actually a pretty good question.
This is Mike Bolger. Do y'all want me to take first crack at that one?
Yeah, sure. Go ahead, Mike.
Okay. So let's see, like Mike Serafin said Saturday, we did pressurize the system above the interface requirement that we have from SLS. However, we don't know if that pressure excursion had any effect on the QD. We're still doing that analysis. We know we didn't exceed the hardware design specifications, but we did overpress the system versus that ICD that we've got. So our engineering teams continue to evaluate what happened there. And I talked a little bit earlier about the updated ConOps, about us trying to have a kinder and gentler, if you will, loading process. One of the things that we're really talking about is avoiding pressure excursions. The only other thing I would say is that, after that, our management team apologized to that operator because we had made some manual procedure changes between the attempt on Monday and the attempt on Saturday. So where we normally relied on an automated sequence, we had folks doing some manual procedures, and we practiced it during the week, but they'd only had a couple chances. So we didn't, as a leadership team, put our operators in the best place we could have. We rely really heavily on our cryo team. They really are amazing at what they do. They deliver for us over and over, and I know that they're going to, again, for the next launch attempt.
And I would just add, that's what really we're factoring into getting ready for the tanking test. Charlie Blackwell Thompson, I keep asking her in meetings like, hey, let's make sure we have enough time for your folks to be ready and practice the loading procedure. So it's front and center for us. And I said to the team, this is we all own the process, and Mike just hit on it well. This is all of us, especially us as leaders, and how far and how fast we're pushing the team. So it was as far as I was concerned, everybody's finger was on that switch.
Thank you. Our next question is from Irene Klotz of Aviation Week.
Thanks, Catherine. Could you just clarify on the FTS if that is a replace or just a retest? And maybe another way of asking the question Bill was asking before is, what do your ground tests show that battery system is good for? Obviously, you already got from the 20 to the 25 days, but how far, just from the ground testing, does NASA think that can be accommodated? And also, what exact date did you put the waiver in? Thanks.
Jim, I guess you want me to take the first cut at some of that.
That'd be great.
So there are retest and replace requirements for any of these systems, right? They have a full useful life. The first one we've been talking about is the retest requirement, like when we go back and we evaluate the end-to-end system. There are useful lives of these batteries as well, so there is a replacement life to the batteries. In addition to the retest requirements, we don't bump up against that particular replace requirement within the waiver request. As far as the data, the range is responsible for public safety. And, certainly if we have our sample size of testing, we've got to show confidence beyond that. And that's their call on exactly what that confidence is. I don't want to get into the details of the testing, but we have used similar batteries for much longer than the request. And I say used, I mean tested for longer than the requested time under arduous conditions. But, ultimately they have to look at that from a statistical standpoint and make sure they believe the enclosure, the safety is supported with that. But, I'll just say, the test data shows considerable time beyond the requested waiver for the retest requirements. Once we get to the end of the life of that battery, we replace that battery, and that time isn't just yet. As far as submitting the waiver, we have talked to the range, and part of that is just understanding what they want us to include. There's a lot of things they need to consider, and so there's an initial talk, and we were able to achieve that shortly after the the attempt that was scrubbed last Saturday. So I believe Tuesday morning I was in that call with them and several other engineers, and then we submitted the next day all the data that they need to take a look at, and then I think the formal format of that may have come out just this morning. So the last 3 days has been constant contact of working to make sure that that we work with them, and we've done that before. This isn't the first time that we work with the range. NASA has a long history of collaborative work with that group in order to achieve flights. So so that gives you the timeline. I think that was the last.
NASA and range collab when?
Thank you. Our next question is from Micah Maidenberg from the Wall Street Journal.
Hey, everybody. Good morning. Mike, you talked about the continuing work on the pressurization a couple of minutes ago. I'm just curious, have any other sort of theories or lines of inquiry emerged about what may have caused the leak on Saturday, beyond sort of that pressurization, which has been described as a possible cause?
Also a good question.
If I'm not mistaken. Thanks.
Yeah, sure. So the teams are still in the field doing the inspections. We'll get the seal out today, and we think we'll learn some more from that. The idea of the kinder, gentler approach is really based on experience, both in the way that Stennis does the green run tanking, and then also as we've reacted to leaks that we've had here at KSC, not just the event Saturday, but other leaks. We've noticed that when we temper the changes, we're better able to manage those leaks when we move more slowly. So we think it's a promising approach to dealing with the issues. Not necessarily going to say that this is endgame, but we think it's promising. And so, again, we're gonna work hard to really try to slow that down. One of the things that we're doing to help with that is we've got some prompts in our automated software where now, as we're kind of transitioning through the various phases of tanking, we can stop when we're going from chill down to slow fill or slow fill to fast fill, and just make sure that we think we've appropriately conditioned the interface and that we've appropriately conditioned the tank. So I wouldn't call it necessarily we're 100% certain this is going to solve the issues, but we do, based on the experience that we've had to date, feel confident that this ought to help us. And let me ask John Blevins if he had anything he wanted to add to that.
Mike, I think you covered the bases really well. I will say that we're NASA, so we do a fault tree and we look at every possible thing, and then we try to use some engineering judgment to focus on the fault tree links that are the most. And Mike just covered those, right? Whether it's that incident that everybody is focused on, or more generally if you will, the pressure and temperature changes and the rate of change. We're gonna work on all of that. And personally, I think it's more the latter. I think this is just a symptom of putting two new systems together and looking at the flow rate, the thermal mass of the systems, and the pressure changes. And now we have that witness. We have the data. We have the leak, and every time we put it together, we learn a little bit. And I think that kinder, gentler, I think that's a great way to refer to it. I think that is consistent with our history, and I think that's going to be a big win for us, regardless of the reason that we had the leak last week.
Thank you. Our next question is from Gina Sunseri of ABC News.
Good morning. You talked about the 23rd and the 27th being possible launch dates. What do those mission profiles look like on those days?
This is Jim Free. So the 23rd is a 6:47 a.m. window open for an 80-minute total window, and the 27th is an 11:37 a.m. Open to the window with a 70-minute duration.
And how long would those missions last?
Yeah, just 1 second. And so the 23rd, that would be landing on the 18th of October, and the 27th will land on the 5th of November.
Thank you. Our next question is from Eric Berger of Ars Technica.
Hi, thanks very much for doing this. Just a little bit more about the tanking test. Is that just the fill to like 8 to 10% that you talked about previously? Is it going to be a full tanking now that you're doing, including the ICPS, it appears? Or is this potentially even a full wet dress rehearsal? Just trying to get a better sense of what your plans are for the targeted 17th test. Thanks.
Yeah. Hey, this is Mike Fulch. I'll take first crack at that one. So first of all, the team's still kind of putting the final details together, but the tentative plan that we're looking at is to do a full tanking of both core stage and upper stage. So, through slow fill, through fast fill, through replenish, and so basically that would be not to the wet dress standpoint where we're trying to count down through a terminal count. We're really just trying to prove that we've got a good seal, and so we think this is a good opportunity for us to do it. And given as much setup time as it takes to get into a cryo event like this, it made sense for us to go ahead and practice, again, both core stage and upper stage. It's also simpler for us from the standpoint of less changes to our procedures and less changes to our software. And so, there's a lot of good about it. But like I said, it's not a final verdict, but that looks like where it's headed. That's our tentative plan.
Thank you. Our next question is from Ken Chang of New York Times.
Hi, thank you. Just wondering, are there limits to how many times the rocket can be rolled to in front of the VAB? And going forward, so what components will be showing up as lifetime limited first? Thank you.
Yeah, this is John Blevins, Ken. I'll take a cut at that to try to explain it well. Certainly, everything on the rocket has some life on it, but when you roll back and forth, and we tend to protect against rolls back and forth, those are complex, and that they're kind of fatigue and fracture calculations. It is a very thorough and conservative process. Let me tell you how we got to where we are. What we did is we took originally historic data, right? The first rollout of this vehicle really wasn't so long ago, but you were building it, you were designing it earlier. And so, what you do is you take the information you think you got and you add a little factor to it and you go analyze that. And so what we did, since we have the same crawler transporter, but we have similar to some other heritage events, we took not just shuttle rolls, but we took empty rolls of the crawler transporter or partial stacks. And when you add mass to that crawler transport, you actually attenuate some of that vibration. And so we combined all of that, though, as a spectra, and we give that to the different elements and programs. And then we go in and we try to design the hardware to be certified to a certain number of rolls. Certainly this particular first flight hardware we've asked a little bit more of than we plan on asking out of future flight hardware. But as far as the certification, initial certification was to a certain level that we have not exceeded. We also measured our vehicle rollout when we rolled out the first time, I believe it was March 17th. And we had that fully instrumented. And in fact, I had the privilege of walking with the rocket while our loads team was monitoring that info, and we were passing data back and forth to Charlie during that roll, and we hit different speeds. And so that rollout itself was a great test to the system. And so we have that data. The different elements and different parts of the rocket are certified to different levels of rolls. We have not exceeded those, nor will we exceed those if we have to roll back and come back. In addition to that comment, I would like to say, just as far as the process goes, there's not a real known cliff here, right? What you do is you calculate how many rolls that you think you can sustain, if you will, from the critical parts. And then you basically divide that number by 4 so that you can have 4 lives, so that you can have margin to that. And so that's why when we talk about rolls, we want to protect against them, because they are an event. They're a broad event. They affect virtually everything on the rocket. There's other factors that play in, Ken, like for instance, we've got to assume a wind when we roll, right? And so what we assume is that we might be rolling back from even, say, a tropical event. And so we estimate the winds to be in the 47 type knot range at the 60-foot level. And so there's a lot of embedded analysis to cover events, and most of those events have not occurred, and we'd have to go back and do a lot of detailed calculations to give a specific number. If we wanted to, say, clear it for a lot of additional rolls, that would be a lot of work to do that. and it would be constrained by what we assume those events to be, whether those rollbacks are during tropical events or whether there are more benign winds, which is what we've experienced currently to date. And certainly those experiences to date help add extra life to the vehicle as well. But to answer your question, you asked what would have to be changed. Every element has something different, and it's really about the frequencies at which you roll. And so those do change with the events. And so it'd really be speculative to give you some bolt or some one single component that had to be changed, because if we did go back and we assessed that beyond our certified limit, we'd be looking at the spectra that we have realized and at that time doing the detailed calculations of what we felt was necessary to go in and inspect and either inspect or replace. Let me just add that I do feel confident the vehicle is in good shape, right? And if we need to use rolls, as Mr. Free said, going back, we're going to use rolls. It's something that as the chief engineer I protect against. Everybody in this call has probably heard me say that, just because it is an event for the vehicle that does add just routine wear and tear, and I don't want to do that. And hopefully, Ken, that answered enough of your question.
Thank you. Our next question is from Jeff Faust of Space News.
Good morning. To follow up on Eric Berger's question, if you're going to do a full tanking of the vehicle, both the core stage and the upper stage, is there any reason why you wouldn't do a full wet dress rehearsal, do the countdown down to T-minus 10 seconds or so, just to buy down risk and make sure you understand everything about the vehicle before you do an actual launch attempt on the 23rd or later? Thanks.
Jeff, I guess I'll start, and John may want to add some to it as well. But I mean, really, the purpose of this event is to prove to ourselves that that the seals that we've replaced are good. We have run wet dress attempts, as you know, in the past, and accomplished the goals that we set out to accomplish. The one piece that we're still taking a look at is we may do a pre-press test where we're getting up to flight pressure on the core stage LH2 tank, which we haven't accomplished. That we may add to this cryo event. That's one of the loose ends that we're still talking about. If not, we'll build that into the beginning of our next launch attempt. But other than that, we feel like the prior wet dresses that we've run have accomplished all of the requirements that we intended to capture as a part of those wet dresses, and so we didn't feel like it was needed. John, was there anything you wanted to add to that one?
Yeah, thanks, Mike. Jeff, each one of these events that we do, is just risk buy down and to some degree maybe risk versus risk. And I think Mike characterized it extremely well that, if we didn't have confidence in some of those things that go in there, we probably would do a full wet dress. I think, you might say that it's been piece parted, if you will, a little bit because of the one thing that we didn't get to and some of the transitions. They're getting down to T-minus 33. But ultimately, at the end of the day, the full tanking does allow us to take one of those things that we've talked about before and was the reason for the first launch scrub, was the understanding of not just the engine chill process, but how we dial those valves in to hit the terminal count just right. And we need the full tanks to do that. And so it's really a risk versus risk. We don't want to get fully tanked and just stay on condition for a long time unnecessarily, because that could that would continue to affect the TPS potentially, not to a point where I don't think we're viable, but you just don't want to do things you don't have to do. So it's really about the questions we're trying to answer, as Mike said, and the questions we're trying to answer, some of them could be answered with just a short fast fill type tanking, but if we want to answer the majority of them, this test that Charlie and the team have devised, I think is a really smart test to do risk mitigation going into the next launch attempt.
Discovery, go at throttle up.
Thank you. Our next question is from Joey Roulette of Reuters.
Hey, thanks. I guess this is for anybody who can answer. Besides the hydrogen leak that you guys are looking at, have you found any other issues on the rocket or on the ground system that might require some closer inspection? And then also for Jim, I think, how late can Crew 5 get delayed from October 3rd before the late October launch period for SLS is taken off the table? Thanks.
I guess Mike or John, if you want to take in the first part of that.
Okay, I'll answer from a ground system standpoint. From a ground system standpoint, we are looking clean. We're not working any issues that at this point look like they would be a constraint for us to get into that cryo event. So we're in pretty good shape.
And from the vehicle, it's a similar story. We are always looking at the rocket. Joey, we're looking at the rocket in countdown. We're looking at the rocket no matter what we do. We're looking at the rocket in the cryo demo that we're talking about. But we have no current constraints to a launch attempt from everything we've observed, and we'll continue to look at the rocket.
And then just to follow up on the last part, it's what I said earlier. We're working with the range to hear back from them, and we're focused on the tanking test. When or if we take those off the table are both dependent on those two things. And then just a clarification, the 80 minutes I mentioned for the 23 September, that's 80 minutes where we'll be lit at launch. The total window duration for that is 120 minutes.
Thank you. Our next question is from Nell Greenfield-Boyce of NPR.
Thanks for doing this. So talking with folks who don't follow space all that closely, some people I've talked to are really having a hard time understanding why fueling the rocket on the ground is proving to be so problematic, especially when it's based on technology that was used in shuttle, and we had 30 years of experience flying that. I know you all have talked about hydrogen leaks plaguing the space shuttle, et cetera, but are these seals and these connections like the same as used in the shuttle, or are there significant differences that are leading to things you all haven't seen before? Thank you.
I guess I'll start and then maybe let John Blevins. They don't let me do technical stuff anymore, so I'll let John Blevins take the back end of that. I guess I think Mike Serafin and I talked about the difficulties with hydrogen and getting the configuration right. And the fact is, shuttle had these problems after 9 years of ops. So and this is the first time we're operating this vehicle, and I think you can say from other launch vehicle development throughout the years, there are challenges when you try and do this. I think the statistics prove that for Apollo, if I just make the Saturn V comparison, leaving aside the commercial vehicles that have had challenges trying to get to their first launch. So John will fill you in on the technical side of it, but from my perspective, it is we're doing this, and it's part of the process and part of what has proved to be the similar issues on other launch vehicles the first time you process them. Go ahead, John.
Yeah, thanks, Jim. Neil, it may look a lot the same, from a long distance. If we had a shuttle out there, you'd see quite a bit of difference in terms of size for sure. As far as this tanking system, every system is unique. There's some things that we did on shuttle that cost us some mass. It was a totally different tanking system, totally different, propulsion system, lines, ducts, and valves, that is, not the actual engines. But, the volumes are different, the pressures are different, the rates of change are different, the seals are different on purpose. It's a design feature. It's not a problem. We will actually get to a very operational status, I believe, very quickly. It's been less than a week since we had the one scrub due, not only scrub due to the leak of hydrogen. Shuttle did get operational. Certainly, there's no question that hydrogen is a challenging molecule, but it's worth it. Hydrogen is the highest performance molecule, and if you look at the mission we're doing, this mission begs to use this fuel. It wants that sustainer, high ISP performance that you get out of really what is the most high-performing rocket engine on the planet, and that is these RS-25s. No questions asked on that. And so the reality is that we will get to an operational status, in my judgment, and that this really isn't out of the norm of expectation. We've changed our process several times as we've gone through the minimal tankings we've done. You can count this on your hand, how many times we've done this between these two systems. And so I really not discouraged about it at all. We do have different pressures, temperatures, and rates of change than shuttle, and we're dialing that in. And that's the part that Mike talked about earlier that is so crucial, that the teams between Boeing and SLS and ground systems are just working together on. And I am very encouraged by the data that I've seen in the last 48 hours and the plan ahead. And so I really, so yes, Nell, it is different. And I think we're going to get that system nailed down in short order.
Thank you. Our next question is from David Curley of the Discovery Channel.
Thanks very much. Mike Bolter, can you tell us about the inspection of the seals? What did they see? Were they in normal shape? Were they ripped? Were they torn? What did they see when they opened up and got the panels off?
Yeah, at this point, we've just gotten a first look. There was an indication on the 8-inch seal. We saw a very minor, I'll call it notch on the 8-inch seal that the team will be taking a lot deeper look at in the hours and days ahead. 4-inch didn't see much. So at this point, again, very preliminarily, there is something to take a look at on the 8-inch, and the team will be looking at that more deeply as we get it out. At this point, it's still actually on the flight interface, so we haven't been able to. As of 8 this morning, we're in the process of replacement, so it may be out now. But the team will take it out and do a more detailed inspection of that entire seal here soon.
Thank you. Our next question is from Chris Gabehart of NASA Spaceflight.
Hi. Yeah. Wondering, just going back to your point about the launch window on the 23rd, and you very specifically only mentioned the 80 minutes of the window that were in daylight. Are you ruling out lifting off at night for SLS on its first attempt based on that comment? Or is the whole window that day available and they can launch at night if the rocket's ready to go at the opening of the window? And also for this LH2 umbilical leak, I'm wondering, you've gone to fuel this vehicle 4 times now with LH2, and you've had an LH2 leak on the TSMU each time, one time actually a repeat. Is this potentially indicating that there's something with the TSMU itself and the design, like that's dragging some of these lines down and creating these potential demate scenarios of the seal that you'll need to look at before Artemis 2? Thank you.
Yeah, this is Jim Free. I'll take the first one. No, the 80 minutes, that's just an error on my part. So the 120 minutes is available to us, and if the team decides we want to use it all, then we'll use it all. I think we'll make that final determination when we get close, but we're not ruling it out right now. And then I guess Mike Bolger is probably the second one's for you.
Yeah, I think with any first flight, when we get to the backside of this and have a successful flight, I think you've heard us say that we think we're on the brink of that. We'll step back and we'll take a look at our ground systems designs. We'll take a look at I know John and team will take a look at the flight systems designs, and we'll see if there's anything that we think we ought to do differently. We do test these interfaces extensively at what we've got a facility called the Launch Equipment Test Facility, where we basically have a mock-up of the TSMU and of the flight plates, and we do extensive testing. We felt comfortable coming to wet dresses and coming to launch that we had a good system. Clearly we have had some leaks. I think like others have said, there can be a lot of things that drive that. We've got new procedures, new software, new flight hardware, new ground systems, and we're going to be taking a look at all of those things to see if there's something that we can learn ahead of Artemis 2 so that we don't have these kind of problems recur.
Thank you. Our next question is from Stephen Clark of Spaceflight Now.
Hi, thanks for taking my question. I want to follow up on Bill Harwood's question earlier about the booster stacked life. John, you said there's minimal risk of that being an issue right now, but is there a point in the coming months where that does become more than a minimal risk, and when is that point? Basically, how long are those boosters good for according to your current analysis? And I'd also like to ask maybe Catherine or Jim, did we get an image of any of these quick disconnects, even a generic type image of what we're talking about, or maybe an image of the enclosure approved for public release? Thanks.
Hey, Stephen, the first part of that, I hate to give you a disappointing answer, but the answer is I'm not really sure, just because I'm working on a few other things and looking at those things. Certainly we can try to get back with you, but, for me, what happens when we have a stack life and we know that we've got a certification for stack life, they'll bring me and John Honeycutt, our program manager, a waiver for us to look at with evidence of why we're good to continue to the next milestone, to the next point. And so I don't really have the data at my fingertips to say what the real stack life limit would be. Certainly, it's about structural integrity of the booster, and we know we have enough data to be out there now. And certainly, we're not going to go beyond what Northrop Grumman provides us for information that's solid on the stack life. So I guess from my perspective, we know we've got it now, and we know that we won't do anything that compromises that integrity. But I'm certain that we've got a few more months left in the stack life.
Thanks, and we can work on an image of that for public release. All right, our next question is from Tarek Malik of Space.com.
Hello, thank you. Yes, my question is for Jim Free about the waiver, and I apologize if I missed this earlier, but exactly how long of a waiver or extension are you looking for with the range for the FTS check system? Is it just through the 27th attempt? Is it through the October 31 window for a period 28? If you can add some clarification for that, that would be great. Thank you.
Yeah, Derek, no, you didn't miss it because I didn't say it. I want to be very respectful of what the range, and by talking about it here, even just on Saturday, I think they felt like we were kind of going outside the process, and I don't want to do that. So I really don't want to talk about the total duration that we're looking for, because that is something that is for us to share with them and for them to determine. So throwing that out there, I think would be a process foul for me.
Thanks, Jim. Our next question is from Marcia Smith of Space Policy Online.
Thanks so much. I'm just trying to get some clarity on the likelihood of the launch on the 23rd or the 27th. So you said that you're targeting the tanking test for the 17th, but that might slip a day or two. So if that slips a day or two, does that rule out the 23rd? And you're not quite sure when you're going to get an answer from the range. So how close to those dates can you wait? I mean, can the range tell you on the 22nd and you can still go on the 23rd, or what does that timing look like?
I mean, I'll give my thoughts, and then Mike Bolger can kind of weigh in from a processing time. No, I mean, we can't wait till the 22nd. I think that's why we have a set of processes that Charlie and the team have to go through and back that time up. But right now, we feel like there's enough spacing between that tanking test and an attempt on the 23rd. If we were to get the waiver. But Mike, I don't know if you have anything to add.
Yeah, no, Jim, I agree. I mean, initially we felt like we needed at least 4 days between the tanking test and between launch. So if it slipped off the 17th for a couple days, I think we could still protect the 23rd. So yeah, I think we're still okay. Obviously, there's a lot of work to do between now and then, and our plans could change. But at this point, we think we need at least 4 days.
Thank you. Our next question is from Liz Hurley of WAFF-TV Huntsville.
Good morning. Can you hear me?
Yes, we can hear you.
Follow up to my question Saturday. The cost in real dollars to 2 scrubs and the cost of public confidence. The answer couldn't come on Saturday, but I'm wondering if you all have the answer now. And to Dr. Blevins, you told me 3 weeks ago in Huntsville that your confidence level was high at the time. Nothing was keeping you up. You had crossed off your checklist. today you all are saying you're not 100% confident that you've been through the fault tree and that the R&R will do the trick for the 23rd. What is your confidence level going into tanking and the 23rd for launch?
Yeah, so I'll start, and I'll probably give you the equally unsatisfying answer from your perspective that I gave you, and then I think the administrator said it best when the cost of failure is much higher than the cost of scrubbing, and I can't say it better than that. We have an obligation to get this right, and if we fail on this mission because we didn't do everything right, then the cost would be incredibly high. And we're doing everything we can to get this right. And as I said the other day, right, we have the people on the mission working it. We have the assets that we own as part of what we do for Deep Space Network and the Space Network itself. And what we're really using is the consumables are the hydrogen and oxygen, and we recover part of that. So we're not bookkeeping it that way right now. We are looking at the future as trying to get to a per mission cost, but we're not there right now. And John, I'll let you handle the other part of that.
Yeah, thanks, Jim. Liz, I'm still sleeping well at night, and the team is working very hard to fix the things that have impeded the launch, as you said. There's a lot more to flying a rocket than launching. Certainly, we've been held up. To speak to that and the confidence there first, I've mentioned it's a new system. I used to design cars a couple of decades ago, and even whether it's a car or a minor overhaul of a design, there's a lot of issues you work through when you put a system together, and those take time. And you guys are going on that journey with us. And I know right now that may lower your confidence. I get to see the inner workings of this team and where we're at, and I feel real good about the ability to pivot and solve the problems that we encounter. As far as the rest of the mission, we have a great architecture. Honestly, this architecture is really fit for this mission. We need high reliability. We're going out into deep space. This is not, driving to the grocery store. This is a mission like you're about to sail into unknown territory. And I feel like we've got the right architecture, the right machinery. It's all been proven to work pretty well. Our first flight's not behind us, and that hasn't changed. And I feel very confident that the teams will solve the problem that's keeping us from a launch, and I feel confident that the hardware will perform as designed. So I still have very high confidence in this machine.
Thank you. We've got time for one or two more questions. We'll go to Doris Arupia from Inverse.
Hi, thank you so much for taking my question. So I'm curious about the impacts of weather on all of this. We did see a few lightning strikes before the first launch attempt. We are in hurricane season, and as the U.S. has experienced a major heat wave, which I'm sure contributes to the strength of some of these storms. So as Artemis 1 is now spending a big chunk of this time on the launch pad, I'm wondering how you are mitigating risks from the weather and maybe just general explainer on, even without all of the work you're doing now to test tanking again, what typical procedures would work in this range, to launch during this beginning of hurricane season? Thanks.
Let's see, this is Mike. I can talk to that a little bit. So regarding, clearly it's Florida summer, and it's a season where we tend to have thunderstorms, particularly, or more commonly at least, in the afternoons. And so it's something that we have to pay attention to, and it's something that we're paying attention to this week as we're doing this SEAL work. We're fortunate from a lightning standpoint. We've got a terrific lightning protection system out at the pad. You've seen the three 550-foot towers that we've got out in the catenary wire that so far has proven really effective in protecting the launch vehicle through a couple tough storms where those towers did take strikes and again protected the vehicle extremely well. In fact, we have so much confidence in those lightning towers that we do allow people to work when we're in a phase 2 lightning storm if they're underneath the protection of that lightning protection system. So from a lightning standpoint, we're confident. We think the system has proven really effective. From a thunderstorm standpoint, we're going to be taking a look this afternoon. We're going to get through this 8-inch seal this morning. Hopefully they're getting through it around now, and we're going to take kind of a 4-hour look ahead. And if we feel good about the 4 hours that we've got in front of us, we're going to go ahead and we're going to do the 4-inch seal. If the forecast is showing us, though, that there's a high likelihood that we're going to have some thunderstorms rolling through the area, then we'll probably wait until third shift tonight when those things typically calm down and come back to third shift and make another run at it. As far as tanking and launches, there's a pretty detailed set of weather criteria that we take a look at. I don't have it all in front of me, but basically, we want to make sure we're not going to have we're going to have less than a 20% chance of lightning during the period where we're tanking. We're not going to launch through, layers of clouds and so forth. We would have to get you more detail on what all of the requirements are, and then, your last part, pointing out that this is the peak of hurricane season. We do keep an eye, out particularly in the Atlantic this time of year and watch the storms. I saw yesterday's report and we were still looking pretty clean for the immediate future. We'll continue to pay close attention to that. And if that changes, then we'll get together and we'll talk about whether we've still got the right plan.
Thank you. And Doris, we do have the weather criteria for roll, tanking, and launch as part of our press kit online. So that's all the time that we have for questions today. Thank you all for joining us. You can listen to a replay of this teleconference online by visiting the Media Resources tab at nasa.gov/Artemis-1 later this afternoon in about an hour. I know we weren't able to get to everybody's questions, so if you do have questions that we weren't able to answer today, please reach out to myself or one of the other public affairs officers on our team. And you can watch a live stream of the rocket on the pad at the KSC Newsroom YouTube channel, and you can follow along and learn more about the mission at nasa.gov/specials/Artemis-Roman numeral 1, and that's all lowercase letters. So thank you all for joining us today, and have a good day.
Interesting. That was a good press conference. I learned a lot, guys. Any questions? Yeah, I learned a lot. That's cool. That gave me a lot of confidence in what NASA's doing. I just always, you know what? I'm going to try to get into a habit of just reminding everybody exactly how transparent NASA is. It takes balls to put your entire space program on display for everyone to see and admit all the potential failures and faults and try to work your way through it. That's really, really cool. It's very easy to just be like, no, they don't need to know that it blew up. They don't need to know that. It's very easy to do that. I really appreciate the transparency. You learn so much from these interviews. Can you give me a TLDR? Sure. I just tuned in. Do we have a new date for a launch attempt? So they're targeting 2 windows right now, MK. Or two days in particular. So the first day is on the 23rd of September. It's a Friday. And then the second day that they're targeting to launch is the 27th of September, which is on a Tuesday. The reason why they're targeting these dates is because, well, the 23rd is open, but they might have a range conflict. Believe it or not, it's not a range conflict with any rockets that are launching. It's a range conflict with using the Deep Space Network, because that's when the Double Asteroid Redirect Mission, DART for short, is going to impact Didymos, the Didymos asteroid, to see if we can perturb asteroids and move them and redirect them. Yeah, so the Deep Space Network is going to be needed that day. So ideally, they said the 27th would be better because there's no conflict with Deep Space Network usage. Now, what's the Deep Space Network? The DSN is something that NASA uses to communicate with anything that's beyond the tracking data and relay system, or TDRS for short. TDRS is at geostationary, so it's in a high Earth orbit. Anything that goes beyond that, you need the Deep Space Network to communicate. So Perseverance, Curiosity, Mars Reconnaissance Orbiter, the Lunar Reconnaissance Orbiter, Maven, New Horizons, Kepler K2, DART, Lucy, Psyche, if it ever launches. All those are using the Deep Space Network. In fact, NASA is so damn transparent about this. If you type DSN now into Google, you can see exactly what they're communicating with right now. The Deep Space Network consists of 3 primary ground tracking stations. The primary ground tracking stations are arrays of antennas that are located basically every third of the way around the Earth. There's one in Madrid, Spain. There's one in Goldstone, California. And then there's one in Canberra in Australia. The big primary arrays here, 70 meters. That's a 210-foot radio antenna. It's freaking huge. They use these to communicate with Voyager 1, Voyager 2. They can go a long way. These guys are 50-meter antennas, so about 150 feet. They're big. They're big antennas. These things are huge. In fact, part of SLS's cost, believe it or not, was upgrading the DSN for lunar missions, and that 70-meter dish in Goldstone is brand freaking new. I wonder how long it will be until NASA has a deep space TDRS network. NASA is actually working with telecom companies, believe it or not, on a lunar relay network. Aqualex, yeah, they're working on that right now. Believe it or not, it's under the Next Step 2 program. Next Step 2 is basically figuring out all the stuff that you need to do sustainable lunar development. Yeah, or do a sustainable lunar program. Next Step has a bunch of stuff like Starship HLS. That's a big one. That is part of Next Step 2. It's a huge program. Yeah, very, very nice. So you can see what the DSN is communicating with right now. So Goldstone, the 70-meter in Goldstone, is communicating with Curiosity right now. The 50-meter dish, number 25 at Goldstone, is communicating with, so that's Mars, nice. Mars Odyssey, Maven, Mars Reconnaissance Orbiter, and the Tracegas Orbiter, which is also around Mars. Look, Canberra 34, communicating with James Webb. In fact, the Spider Nebula picture is amazing, and you all should see that. Just while we're there, while we're on the subject, James Webb imaged the Spider Nebula, and it is that doesn't suck. Forlorn, I think you got one of those wrong. See all these blues? All those blues are brand new stars that the Spider Nebula is creating. All those blues. Yeah, I was reading about this morning when I woke up. Oh, dude. That's really cool. I want to go there. Is that bad? Can I go there? I want to go there. Can we just solve that faster than light travel thing so I can go there? That would be really cool. But anyway, yeah, Spider Nebula. The reason why it's called the Spider Nebula is literally because it looks like a spider. See? I mean, doesn't have 8 legs, but close enough. So that image from James Webb is the center of the nebula. That's right there. That's hence all the new stars. That's right in the center. That's a close-up shot, which is just frick me. That's cool. Oh, that's really, you can tell it's a nebula because of the way it is. And you know what? That's pretty neat. But anyway, so 23rd is what their launch attempt is, fellas. Going back to the SLS explanation, they're trying to target the 23rd to the 27th. That is all very contingent on obviously Deep Space Network usage, but it's also contingent on a tank filling test. So right now, like literally right now, if we go to KSC press room, hang on, KSC newsroom, I bet you can see what they're working on right now. Yeah, they have an enclosure. Yep, there it is. They have an enclosure over the tail service mast umbilical, and they're taking that seal out right now and they're replacing it. that's going to be crucial to figure out why that seal did that. NASA's really trying to wait on. They're going to replace the seal. Obviously, it needs to be replaced. But an important thing to understand is why that seal got pinched. They said there was a scoring mark on the seal. So literally somebody pinched a gasket. Yeah. Or something caused that gasket to pinch. Now, why is that? Okay, you know what? I'll keep the explanation short. So they're going to replace the seal, and they're going to do a tanking test to see if this is repeatable. The tanking test is just conditional operations for fueling the hydrogen and oxygen tank, and that's it. That's all. But you see the tent they have right there. So you guessed that. Yeah, Nikita. I think I can't prove it that somebody over-torqued it. I have no idea. NASA will certainly tell us if that's the case, but they don't know. They don't know for sure. See last on DSN now. Better get a cryo chamber. No, I want to go there like in an hour. The squiggly lines actually do mean upstream and downstream comms, right? I noticed that 53 is only getting downward. Yeah. It's sending and receiving. Parabolic antennas can send or receive. It could also be a poor design. Starch, I have thoughts on that. Long story short, it's really easy to say it's a poor design after it's not worked. But you won't know that it's a poor design until you actually try it. That's why I appreciated the response to the NPR lady's questions so much. Yeah, it's based off of the shuttle. Yes, the shuttle did have hydrogen problems. That is a thing. But they figured it out with the shuttle. The thing is that the tail surface mass carrier umbilical plate is derived from the shuttle. It's derived from the shuttle. It's not exactly the same thing. First of all, you need to flow a lot more hydrogen into that core stage than you ever needed to with the space shuttle. So even if you're using a similar fill rate, even if you flow at the same, you have the same, slow fill and then fast fill and then replenish, you're still flowing way more fuel. And that's way more time that the seal is chilled down. That could screw with it. Long story short, like I said, that's a really easy thing to say. And I'm not trying to be a dick. It's just a really easy thing. It's really easy to say after something has gone wrong that part's junk. That's why I don't like the term design flaw. Design flaw is a catch-all term. It's a catch-all term used by people that don't understand analysis. I don't like that. I really don't like that. So it did work on rehearsal and the first launch attempt. That's right, Mullet. Yeah, they did initiate manual slow fill on the first launch attempt and on the second launch attempt, and it worked on the first one. It didn't work on the second one. So that's mixed signals. The seal is sending you mixed signals, so to speak. Like you talk in relationship terms. It's sending you mixed signals. You don't know for sure. That's why NASA deemed it best to take the seal out and figure out. Look at the seal. Literally look at it. Take it out and look at the damn thing. Why is it pinched? Why did it pinch? As long as it gave you data, there's no such thing as a failed test. Yep. Star 1. Okay, Miles. So do I understand it correctly that the solution for tanking issues is to have more manual overrides to adjust the flow rate to keep the temp expansion deltas nominal? Or so they will now tank SLS more on field than on tested repeatable automation? They don't know what tested repeatable automation is yet, Miles. It's a test flight. Right? So you're kind of right, but you're kind of not. They're not gonna do manual fueling on every single SLS flight. What they're trying to do right now is figure out the right way to flow it and then adjust the auto sequencer down the road based off of this. Yeah, the best scientific experiment. You're on. Yeah, the dang old Mark 1 eyeball. So, long story short, they're going to replace the seal. They're going to do a tanking test on the 17th and hopefully target late September, so the 23rd or the 27th. My gut is telling me the 27th. They don't want a DSN conflict with DART. That'll give you more time to assess the data. So I'm going to guess they're going to try to lock in the 27th. The other thing is that the flight termination range batteries on the core stage need to be recertified. So NASA submitted a package to the range, and the range is going to see if that proposal is acceptable within safety limits for the flight termination system of the rocket to basically keep it out on the pad. NASA is avoiding a rollback. They're Jim Free talked a lot about this, and so did John Blevins, for what it's worth. They don't want to roll back. Rolling back induces stress on the vehicle. It is an event that will put the metal through somewhat of a load cycle on the vehicle. Now, I know the next question coming. What are you saying? Like, they can't roll it back? No, not at all. Of course they can roll it back. What I'm saying is that's going to screw with their test data. It'll screw with it. Because if you think about, so consider, like, go 5 years into the future, right? What does an SLS mission look like? Presumably they got all of the problems figured out, and we're rolling Artemis 3 to the pad to launch people to land on the moon, right? What does that ideally look like? You stack the vehicle gets stacked in a month. You roll it out to the pad. You do one roll to the pad. That's all you need. One roll. You do one roll to the pad. You set it down. You hook up all the lines. You do all the tests. You initiate launch. People get aboard. Boom, you launch it into space. That's one roll. That is what ideal testing data looks like. NASA is trying to get as close to that as they possibly can. The thing is, this thing is rolled back and forth from the pad multiple times, and it was used for the green run before that. They don't want to screw with the data as they want to try to keep the data like as baseline as possible. And rolling back and forth from the pad again is basically screwing with your baseline testing data. Remember, this is supposed to be basically the trial run. This is the final exam. All right, maybe not more like a final. It's more like a beta test for the vehicle. That's why NASA's changing everything and just trying to figure out ways and why they're having problems with it, because it's a beta test. Honestly, if you beta test let's switch it around a little bit. Let's talk in the context of software. If you beta test software and throughout the beta test you find no problems, you didn't test good enough, right? That you didn't test good enough. There's no way that you designed some sort of software package that worked perfectly on the first try. No way. That never happens. Ever. I'll tell our tester that. Yeah. There is, just like KSP with mission mode. Well, Team N mission mode was designed to teach you guys about this. That's why I built it that way. See what I'm talking about? You're never, Predominant's like, I'd do that every day. Come on. Jokes aside, dude. Have you ever designed code that worked perfectly the first time in a software package? There's no freaking way a complete software package is going to work perfectly the first time, unless everybody's really on their game, or unless you designed it yourself, right? You build with tests, so you're going to make me scrum. So you build with tests every day. So this stuff is going to happen, guys. This is the beta test. It's the beta test. They're going to run into unknown unknowns. How are they supposed to know the seal wasn't going to work? It worked before, but now it's not. Does that sound like software to you? Oh, it worked before. What did we change? Why doesn't it work now? That's what they got to figure out. That's really, really, really important to understand. It's so important. It could be potentially a problem with hydrogen fueling, and then you could actually spring a leak and liquid hydrogen could come out the bottom, and then you get a Hindenburg instead. You don't want to screw around with this. You really want to take it seriously. You really want to understand why that seal is doing what it's doing. The fuel line, the main fuel line to the vehicle is kind of important. Like, it's kind of important. Just putting it out there. You kind of need that. Unknown unknowns happen. For real. Bingo. Hello, world. Oh, CS50 jokes. Yeah, kind of, just a little bit. So, yeah, they're gonna figure out what's going on with it. They're gonna figure out what's going on with it. They're gonna figure out what's going on with that seal. They're gonna replace it. They're gonna understand the dang behavior. They're gonna do a tanking test. It's gonna freaking work, and then we're gonna see a launch in a couple of weeks. And you know what? It's gonna be amazing. It's gonna be freaking amazing. Also, I didn't know that John Blevins worked on cars. He was that's really cool. He apparently worked at Honda. That's really neat. Because, see, that makes me happy because the car analogies, man, the car analogies are legit. They work. They work, man. It's going to be amazing. End of story. Yeah, Ragathor, it's going to be awesome. Just give him some time. Trust me on this. But isn't this cool? Isn't this cool being right there with NASA, learning about how this works? SpaceX does stuff like this every day. Like, don't get me wrong. They absolutely do. SpaceX is constantly building, testing, and learning and trying new things and blowing stuff up. Like, they constantly do that. But we don't get the transparency that you get with NASA. Like, NASA, we're with them every step of the way and learning what their thought process is and learning how you fix these actual problems. Like with SpaceX, don't get me wrong. We get NSF coverage. Speaking of that, the booster 7 is being primed for a test, from what I can tell. But we only kind of see this, right? We don't get to talk to the engineers and interview them and understand where they're at and understand where their head's at and understand the engineering behind the vehicle. You don't get that with commercial. You just don't get that. It's so cool. What's the status? They're taking the seal apart. They put a little blow-up tent around the TSMU snack. Let's see it right there. This is a live shot, by the way. They put a little blow-up tent on the TSMU, taking it apart, going to check the seal. They're going to replace it, and they're going to try to figure out why it leaked. Yep. They work because in the end, it's all just engineering. Yep. Meanwhile, Starship is getting nice and chilly. Yep. What about the batteries? They submitted a package to the range panic, and the range could approve or disprove it. Basically, once again, NASA's trying to avoid a rollback so it doesn't screw with their baseline testing data. That's the short story. This thing's already rolled enough to the pad back and forth where you're going to have to take that into account. You're going to have to take into account mode changes between the VAB and the pad because it rolled back and forth from the pad so much. Is the first stage Boeing? The big cylindric orange section is the core stage. Core stage was engineered by Boeing. At the bottom, you have 4 Aerojet Rocketdyne RS-25s. They're RS-25D engines, if you really want to know. Those made by Aerojet Rocketdyne. The boosters on the sides are 5-segment solid rocket boosters. They're made by Northrop Grumman. Vehicle stage adapter, the LVSA, this conic section right there, that's made by Boeing. The interim cryogenic propulsion stage right there, the one with the flag on it, is made by ULA. And that has an Aerojet Rocketdyne RL-10B2. And then up here, the European Space Module is made by, I think it's the European Space Agency, but I think more specifically it's Thales Alenia, I think. And then the Orion capsule up on the top is made by Lockheed. And then the launch abort system, the LAS on the top, is made by Northrop Grumman as well. So the possibility of the range tell them they have to roll back and swap the batteries. Yeah, it's a possibility, Panic. Yeah, sure. Yeah. A rollback isn't like a death sentence for Artemis 1. It's not a death sentence. It's just that's just more data to comb through because remember, it's about getting a baseline test. Like once again, picture the ideal launch. What does an ideal launch for SLS look like? You build it in the VAB, you roll it out to the pad, you put it down on the pad, crawler transport gets out of the way. You know, it's there for a week, just checking out everything. You get to launch day, you feel it, put the people inside, launch it. That's the ideal launch, right? How far has Artemis 1 deviated from that? See what I'm talking about? That's what I mean. So what is the Artemis 1 core stage done? It was built at Michoud, then it went to Stennis to do the green run, right? They fired it, fired all the engines, they recycled the engines, they sent it to the Cape, it was stacked on the rest of the vehicle. They did testing with it inside of the VAB. They did umbilical testing with it. They did modal testing with it. They did mass simulator testing with it. They did load testing with it. They rolled it to the pad, wet dress rehearsal, rolled it back to the pad again, wet dress rehearsal campaign number 2, rolled it back to the pad again, launch attempt number 1, launch attempt number 2. See how far that's deviated from what the ideal like baseline test would be, the more you get away from that ideal test, right? The more data, the more time it's going to take to process what the baseline data is. Understand? Predominant, stop swearing, man. You're getting timed out because you're swearing, not because you're wrong. Guys, calm it down, all right? Calm it down. Sum it down now for me, okay? But yeah, it's just panic. I mean, the range could say, go frick yourself, go back and fix it. Because we're not going to risk the rocket like flying off course in the event of a, you know, out of track scenario and going and crashing into Daytona Beach or something. We're not risking that. Frick you. Change the batteries. They could say that. Or they could be like, okay, we understand we understand that you're letting these go longer than what we certified for, but you can confidently prove with data that they will be okay to stay out on the pad for another month, and then we're good to go. You know what I mean? Who's the fastest vehicle around Daytona? Give him some time, guys. NASA will come through. Trust me on this one. Once again, they said it at the very end of that press interview. Actually, not once again. I haven't reiterated yet. They said it at the very end. They said it at the very end of that press interview. Look, this is the big leagues. This is hard. It's very difficult. They're not just launching something into low Earth orbit here. Okay. This is beyond low Earth orbit human spaceflight. This gets complicated very quickly. You got to be careful. You got to make sure you're as confident as you can be in your abilities to make this thing fly and be correct on the first time. Sounds like someone is a case of the Mondays. Nice. With the Starliner skip testing and the 737 MAX hidden function to cover for undocumented aero behaviors, I have to be a bit worried about anything new from Boeing. I can only hope that it's not new. This is based off of previous designs. I mean, it is a new vehicle, but guys, all right, fellas, all right, look, Starliner, SLS Core, 737 MAX. You know that Starliner and SLS are a different company, right? Like, you know that's Boeing Space. It's a subsidiary of Boeing. That is very different than Boeing's commercial airline division. Those are two separate companies. Like we know this, right? And then yeah, the blue KC-46 and Air Force One are Boeing Defense. That's Boeing Defense. That is a different company. We understand that these are all. Give me 1 second. What test did Starliner skip? Starliner didn't skip any tests, guys. They found a problem with the timing mechanism on the first test flight. That's when guys, I'll be honest. That's when you want to find these problems. And before anybody says, well, NASA's done this in the past and they haven't had problems. Yeah, Apollo 6 almost shook itself to pieces on the way up. So these problems do happen. You guys know they did 2 test flights with the Saturn V, 2 uncrewed test flights with the Saturn V, and the pogo oscillations were so bad on Apollo 6, the payload almost shook off the top of the vehicle. True story. Guys, you find it, this isn't like, oh, well, we don't know how to do it now. No. You can't. The engineering and the way spaceflight works, the stakes of the game with spaceflight like this, can't screw around. It's different. You can't screw around with this stuff. Yeah. This is the test flight business. That's right, Eric. You got it, man. So, people are saying, oh, Boeing made the core stage. I'm not confident. You guys, that's honestly a really lukewarm Bush League take, to be 100% honest with you. That's a really weird point of view. One, like I said, oh, hi, Brimo. Brimo bought food and pizza and mac and cheese. That's a really weird thing to say, because one, Boeing Space is a different Boeing Space is a different company than Boeing Commercial Airliners. It's a totally different company. It's just under the same roof. Hello. Is this all mine?
No.
I was gonna say. How you doing?
I'm sleepy.
Sleepy? Have some Coke.
That's what I got.
That mac and cheese? You brought me mac and cheese and pizza? And chips? You're good to me.
Also, I got this as part of my order because I couldn't decide what I wanted. It's a chicken teriyaki bowl. So if you get hungry later, with broccoli.
Don't twist my arm.
I know. I just thought I'd let you know. But I was gonna take this back to. I'll take it back to the house.
You really are sleepy. You're sleepy. Sleepy today.
I am. I wanted a warm sandwich.
That's fair. Thanks, babe.
Yeah.
Brought me lunch.
I did bring you one.
Did I tell you that I love you? Have I mentioned that recently?
You might have mentioned it.
Yeah.
Yeah. Oh man. Ghost mode. Oh yeah, I guess I am ghost mode.
Why is it chromating out that green? I can't see colors, and I know that's a different color. It's not even the same.
It's not like total chroma. It's just like a little chroma.
I don't know, Red. I'm still trying to figure that one out.
All right.
All right, sweetheart.
I love you.
Love you too.
I'm gonna go turn on BBC. They put out a warning that the doctors are concerned for the Queen's health. I know, right?
Somebody found a DeLorean. Wait, what? All right, so yeah, fellas, we can talk more about that during space news if you really want to know. But yeah, long story short, they're working through the problems, man. Work the problem. This is Apollo stuff, man. You're getting into the big leagues. Oh man, I don't know. Like I get it to have concerns and stuff, but we're not involved with the rocket. The rocket fails, no skin off our nose. You know what I mean? Like we just sit there, get the popcorn, and watch how awesome this is. It's really freaking cool. Now, once again, a lot of you guys are newer spaceflight fans. A lot of you guys weren't here for the shuttle program. It's special. It's special when NASA goes to launch something. It's very special. It's totally SpaceX is awesome, but it's a totally different vibe. Trust me on that one. It's definitely different. Yeah, W, I see it. Is that Panera Bread Pizza? Yeah, there's a Panera somewhere in town. I don't know where it is, man, but it's a little ways away. They can't fail, Turing. And yeah, that's another thing that Jim Free said that really made me happy. Jim Free is NASA in charge of NASA's exploration systems development. So basically, he's in charge of NASA's human spaceflight R&D program. That's a nice way to say it. He handles all the new stuff that they're gonna work on. So Jim Free is in charge of figuring out he's in charge of the program that's gonna figure out better SLS upper stages and upgrades for SLS and Block 2, SLS Block 1B, upgrades to the universal stage adapter, stuff like that. That's what he's about, which is actually super cool. He basically said they can't fail. They can't fail. They can't fail. We can't fail at this mission. We'll take as long as we need to get this thing off the ground, but we have to make sure that it failed. This mission cannot fail. We will not let this mission fail. We will do everything in our power to make sure that doesn't happen. That's you know what, man? In this day and age, accountability is a rare commodity, all right? I appreciate the accountability. And they also said the other thing that him and John Blevins were talking about is that, you know, there was an overpressurization event in the hydrogen line that may have caused the seal to get pinched. And they said that that was their fault for not teaching their operators changes in the system. That's accountability right there. That's, you know what? I'll call it out when I see it, but in a good way. That's a good thing. You need to take ownership of these problems. It's your rocket. It's your baby. You got to take ownership of it, and they are. And I really, really appreciate it. It's really cool. It's really awesome to see. Trust me, everybody, you guys are in for a treat. This whole launch campaign, NASA's telling a story. This is going to go into the history books, and it's going to be amazing. We're going to be watching this on a documentary 50 years down the road, and you're going to be like, I remember when that launched. It's going to be sick. Or it was sick. It's going to be sick because we're still in the present right now, right? You know, no blame, no excuses. Take ownership of the problem and fix it. Simple as that. That's spaceflight. You have to. You have to be that way. Can't blame people. You can't blame people. Don't say that, Acid Paintball. Come on now. Yeah, Eric, that's the other thing. The other thing, dudes, is that, look, Apollo was 50 years ago. And yes, there are a lot of people around that worked on the Apollo program that are still around today. But this is a new generation. It's a new generation of people. Just because you have a new generation of, say, like fighter pilots, does that mean they don't need to be trained? No. We're starting over, basically. We're starting it up again. And this illustrates the reason why you never cancel a space flight program. Ever. Bad idea. Because once you jump off, once you get off the horse, it's very like, let me say it this way. It's very easy to get off the horse. It's very tough to get back on it. You know what I'm saying? That's a really hard thing to do. You got to build up momentum. And, you know, we're teaching a new crop of people, a new generation here of scientists and engineers, what it takes to send people beyond low Earth orbit. It's very inspiring stuff. It's really cool. Engine shield looks to be 3 or maybe 4. All right, let's see what's going on down in Boca Chica. So just sit back and enjoy it, guys. Should be pretty cool. Did I see your last? No. Sorry for the stupid DSN questions, but one antenna is talking to Forecraft and the others are one each. Is it a bandwidth issue or just not a fit? I don't know enough about parabolic antennas to say, Rain. I'm sorry. Radio signals are black magic to me still. Or radio waves. I'm still like, how does that work? Magnets? No, they explicitly stated that they were skipping ground integration tests and spun it as a positive before the error. They admitted they would have caught it in integration tests. They may be different subsidies, but they're still competing for investment from the parent company and can be subject to having the parent company shovel the, yeah. You see, all your thing is based off of speculation, Aqualex. I'm willing to give these people the benefit of the doubt because it's NASA, and NASA can't be seen failing. But I mean, you know, you can make an opinion stated as fact based off of how you feel all you want. That's fine. Like that's fine. If you want to be that way, that's cool. I choose to not be like that. SLS is gonna work. It's gonna work great. Besides, the seal isn't even Boeing's problem. The TSMUs are made by Jacobs. Yeah, the TSM, that's who manufactured those. So it's not even Boeing. The core stage isn't malfunctioning. In fact, the core stage is working exactly as intended. So, I mean, look, I get it. It's fashionable to dump on Boeing nowadays. I'm willing to give Boeing space the benefit of the doubt. Teething problems happen. You know why? It's because when you decide to stop flying things into space for a long period of time, you don't just inherit the data the data and the expertise from past programs. You do have that data to rely on, but at the end of the day, you're always going to run into unknown unknowns. And writing off Boeing space is like, oh, they have no idea what they're doing, is very arrogant. And honestly, it's I'm kind of ashamed that you have that take. That's really messed up, man. What a slap in the face to the thousands of people that work on this. Way to just, you know, undermine everything that those people do. I really, really don't appreciate it when people do that. Yeah, it really is annoying. Don't do that. You don't know better. I'm sorry, you don't. And it's really easy to point out these problems in hindsight. That's a very, very easy logic trap to get stuck in. Don't do that. Do I have to be classy now, please? Like, it hurts, man. Like, dude, I'm not saying that I'm any expert either. What I'm telling you is that I don't know, and neither do you. But, you know, like, I'm willing to give these guys the benefit of the doubt. I know they know what they're doing. We're changing the game, man. We're getting back into, you know, going back into space. Stuff's gonna happen. You have to fix it. You know? You're always going to have teething problems. Ask anyone that works in aerospace. This stuff happens. These are minor problems in the scheme of things.
Discovery, go at throttle up.
Rotor, Houston, go at throttle up. Anyway, let's take a look at what's going on down in Boca Chica, shall we?
To most? Is it the 33 Raptors firing at
mind if
once,
I
a belly
eat
flop,
my
a
food?
catch attempt, or something different?
I'll be right back.
You know, that's a good question. Honestly, I'd just be happy to see this thing launch. So I guess 33 Raptors would be it for me. The belly flop would definitely be cool. Catch would be cool, but yeah, I'm just looking forward to the launch.
Yeah, I would probably say the same. It's like we've been waiting for so long that just seeing it lift off will be okay for me. If it lands or not, that's okay. I will point out that right now it seems like maybe it is. Now OLM vent has stopped.
Yeah, maybe.
Finally, maybe.
Yeah,
We'll
how
see.
long does it have to be stopped before we say it actually stops? Alright, so yeah, I mean, there's like that little trickle, but it's not like actively venting anymore.
Mhm.
So again, to point this up, well, and there it
Oh,
goes
come
again.
on.
But so here's what we're looking at, chat. If you look at the left-hand side, like Alex mentioned earlier, right in the middle of the camera view on the left, between the legs of the orbital launch mount, you can see just a little bit of venting from a pipe that's near the base of the mount, and the venting has subsided there. Every once in a while there's a little bit more, but as that venting subsides, that has usually been an indicator of propellant loading or beginning to load methane and or liquid oxygen into the vehicle. So that's why we're looking at that. There are some other indicators that we'll hopefully start to see around the launch mount and on the vehicle itself to indicate that propellant is on board the vehicle, which we haven't seen just yet. But that's why we're showing interest in that, is because it is the next indicator we'd expect to see. But anyway, sorry about that. So Nick, you're saying the initial liftoff is probably what you're looking forward to, since you'll see that.
So I did see my first rocket launch ever just a couple weeks ago out at the Cape, that Starlink that night launch. That was really cool and really special. And yeah, I think honestly, maybe if I can revisit that answer, perhaps I'm most looking forward to the leading up to the orbital launch flight. I think it's really going to be fun the few weeks before, and as we get up to that morning of and the day of, and all of the excitement and buzz and work that we'll all be putting in as a team at NSF, getting everything ready, bringing you guys the best coverage. I think that's going to be really special for me, because the launches, they go by so fast. I mean, wow, it's over.
Yeah,
in
what are we just saying? Like 8.5 minutes, right?
Yeah, I mean, something like that. I mean, the Starlink Falcon 9 was gone in about 2 minutes, 2.5 minutes or so. And it's like, okay, yay, it's gone now. Now what?
Now we wait for the next one because there's a million of them. But
Yeah, exactly. You just gotta wait 48 hours. But yeah, out here, I think it's gonna be that build up to it, and then obviously having a successful flight. That those 2 minutes of flight will be very exciting. But yeah, belly flop and catch will just be icing on the cake whenever that happens.
all right, Alex, you're up. What part of the flight are you looking most forward to?
Yeah, I already said before that I think probably launch is the thing that I'm looking forward the most, because it's like I don't really care if something wrong happens afterwards unless, it destroys the OLM or something, which I totally wish it doesn't happen, obviously. But just the launch itself, it's something that I'm looking forward the most. Afterwards, it's just like, yeah, it's flying, okay.
Right,
And
because again,
also,
the
I will
learn things,
say,
right?
yeah, and also I will say, not just the first launch, but multiple launches. Like I'm really looking forward to the point where Starship is something more regular than, maybe it will happen or maybe it won't. I think that will probably ease some of the concerns of people about this rocket.
I think my favorite moment is going to be hopefully a successful SECO, Starship engine cutoff. I don't know, whatever the acronym will stand for in that sense. But when you get a vehicle to their nominal velocity target, I think that'll be the big thing because we've seen Starship actually attempt a belly flop and landing before, obviously not from an orbital reentry, but I think if they can reach a successful SECO into a nominal orbit or a slightly lower orbit, whatever flight profile they eventually agree on, that would be out of the park. And any experimental recovery that comes after that is a bonus, whether it's with the booster or the ship. I also say, I'm very excited to see what 33 Raptors firing at once looks and sounds like, but I also have a gut feeling that they will at least try to do that before the actual launch itself with just a static fire test. So I'm not going to say that's my favorite part of the flight because I think we'll actually see that before the flight. But that is, of course, just a prediction. But a good question there, Mike. Appreciate that. Chat also saying that SpaceX is watching our live stream and changing the OLM vent just to troll us, and honestly, wouldn't be that surprised.
Yeah,
Other
funny
questions?
story. I was actually stopped on the side of the road yesterday. I was taking a clip, and a SpaceX engineer pulled over, and he's like, "Oh man, I love your guys' streams. You guys were just streaming the work on Ship 24 because yesterday they had some people up on the boom lift." And he's like, "Oh, that was me. I was so excited to see that." And I was like, "Nice job, man. You do the cool stuff though. We just take the pictures. So we love you,
Yeah.
SpaceXers."
As Das says, we capture and relay photons, but we are grateful for the opportunity to do so.
Oh,
That
okay.
vent has definitely
All
calmed
right.
down. Before we dive into more questions,
Your boy
I think
your boy ate that way too fast. All right, hold on. I still got a couple more chips. Give me 1 second. MC Kens, light that candle. Let's go. Let's go. Did you chew it? Like, that's the thing, man. I can't be away from the stream for that long. Or let me put it this way. I don't like being away from the stream for that long, so I usually scarf food. And I will tell you that that's not good for you. That's a really good way to get indigestion. So I'm trying to not like do it as fast. At least get like 10 chews in there, But also I've been trying not to eat on stream either. So.
Pipe there connected to the water pipes that.
Yeah. Yep. Yeah, Lucky, I know what you mean. Sometimes, man, I'm just really into powering through food. like some foods you eat slowly, right? Like if you have a New York strip, nice steak, take your time. Steak, the fine Chianti, some rice and some broccoli, it's buttered. Yeah, now you're hungry. Sorry. I ate his liver with a fine Chianti. But yeah, some food I just like scarfing. You know what I mean? You putting in a garden next growing season? I think so, farm. Oh no. Sometimes it goes down. So yeah, no, Lucky Charms, yeah. Dude, I used to get bad stomach aches from eating too fast, from getting indigestion, and then your body's like, your stomach's like, wait, this is not. What is this? I don't know what I'm doing here. Farmer EG, content I didn't know I wanted, get a Lamborghini tractor. It's too big. Anyway, sorry. I don't think I have a big enough property to warrant even a small tractor. I have a ride-on mower. Does that help? Ain't gonna fit. Won't fit. But yeah, farm, I'd love to. I'd love to start a garden and stuff. That'd be cool.
Discovery, go at throttle up.
Lavi, I'm really into that whole self-sufficiency thing. It's really nice. I really like it. I really like having my own place. And like, I mean, like, don't get me wrong. I'm not some like psycho. Like, not. I mean, kind of. With the spaceflight stuff, I tend to go off the deep end a little bit. I'm not gonna lie there. I'm not gonna lie to you. But you know, that I recognize that, so I'm not as crazy. It's catch-22, right? If you admit that you might be crazy, then you're not crazy. But if you just straight up act crazy, you know, then you might be crazy, right? Where'd you say they are in the process? I don't know. I was covering SLS stuff here, the SLS press conference, so I'm not really sure where we are in the timelines here. But that whole self-sufficiency thing is kind of cool. I like doing that. Not because I'm trying to prove any point. It's not about... It's like playing Stationeers in real life. It's cool, man. I dig it. Literally, gardens, get it? Yeah, I do that kind of stuff because I think that's neat. You know, I do it to prove to myself that I'm normal. You know what I mean? Like, sometimes you need some just normalcy in your life. So when you're building your vault, now that's crazy. Hey, Meyer, what's going on, man? Now it's time to plant garlic. What if you say you're crazy and then you act crazy? Well, human, if you say no, catch-22 is if you say you're crazy and you act crazy, then you're obviously not crazy because you're declaring yourself crazy. But if you're not crazy and you do crazy things, then you're also not crazy because you're not crazy. Catch-22. It's a good book, by the way. I'll go to here in Norway. How are you? I'm good, man. Just sitting here watching this grain silo vape. Pylum, yeah, there you go. Hey, Meyer. Dude. Have I ever showed you this on stream? I know you're a slight newer viewer, but one of my buddies that's in, I think he's in Tromsø, sent me this. I have this in Vespa Ball. Got a Norwegian care package. Vespa balls are amazing. I have packages of it. People are like, what the heck is that? I'm like, it's Vespa ball, man. Yeah, JDG, that's right. North Wilkesboro's coming back to host the 2023 All-Star race. Oh, so cool. Yeah, Solo's delicious, man. It's like Fanta. Reminds me of Fanta, but Norwegian. Uh-oh. Coder took a dump. Hold on. Oh.
We've seen that they probably are even coming from the same production line, and it's just the other bits are modified. So yeah, we can see that there's some simplicity in being able to produce just one.
They changed scenes, guys. They know about it. Michael's probably handling it if I had to guess. Mike Baylor does all the back end for this stuff. Also, that's the guy that does Next Space Flight. They do have HESCO barriers there. Yep. So they're hopefully doing some kind of static fire, but yeah, you know what? I'm gonna switch this, guys, to kind of the background there. Dust needs to build better cameras. You guys want to hear a fun piece of trivia? You see this camera? So, you know how Dawson and I have been talking about solutions for automotive streaming, right? Dawson was actually building a PTZ camera for the garage for the longest time. This was like, we've been talking about this for a little while. This would have been like in my parents' garage, right? So we're talking about doing this for a little while. It's a PTZ camera that the mods can control, so I can auto stream by myself and have a cameraman, have a camera be remote controlled. Turns out that DOS is really good at doing stuff like that. You see this camera right here? DOS built the camera. He built the PTZ camera that he was going to ship to me, and then shipped it to Boca Chica, drove down there and hooked it up. This is supposed to be the auto streaming PTZ camera. You can tell him. You can ask him. He'll tell you. This is the auto stream PTZ camera. I thought it was fun. I didn't care. I thought it was funny. I'm like, sweet, because it's funny because I can tell this story. I have a habit of doing homework with you in the background. Did you change something? Because I can't hear any background noise, which is kind of strange. I have a noise suppressor on, dude. Yep, I did, Forge. So, okay, so I have a noise suppressor. So I have a noise gate on the mic, but also the drop ceiling that I put in is an acoustic drop ceiling. There's no reverb from it in here. Yep, it's done. Well, this part is done. I have to do the angled part behind the green screen, but that's another story. But yeah, I took the lights down and I hung a drop ceiling over the weekend. That's why I wasn't here Saturday, Sunday, Monday, because I was working on this. And I have R30 doubled over insulation on the top. Dude, this place is a freaking ice box. How did you drop the ceiling? With gravity, obviously. Is it registered with the ATA? I see what you did there. So, Forge, fun thing about that, you don't hear the rain because of the drop ceiling anymore. Second part of that is you do hear the rain in the main shop. So, if we're auto streaming in the future and it starts to rain, you will definitely hear it. And it sounds better in there than it did in here, to be honest. All right, fellas. Well, I think I'm going to switch this over to F1. I see a little frost ring there starting to form. So even if this thing does static fire, it's going to be a little bit, probably about, I'd say 45. I'm not going to guess. I was going to say about 45 to an hour, but it's very clear that they're chilling down things here. They're doing the same kind of thing that NASA is doing. They're slow flowing liquid methane here into the booster. You could definitely see condensation starting to form right there. And there's also a frost ring right here, indicating that GN2 is loaded. So these chines right here, see these things on the sides that look like wing strakes almost? Inside of those are composite overwrap pressure vessels. It's basically a gigantic scuba tank that's wrapped in carbon fiber. It's a COPV is what it's called. Inside of the chines there, or those winglets or herpaderps that you see right there, there is nitrogen tanks. GN2, gaseous nitrogen. They're nitrogen tanks. And what are those nitrogen tanks doing? those nitrogen tanks contain the pneumatic systems to start the center Raptor engines. So these things in the center are super heavy. Now, don't get me wrong. That's an older design right there with 9 engines. This booster has 13 of those. So you have 9 around and then 3 Raptors in the center, kind of like Starship right there, instead of that configuration. So there is frost accumulating on the chines, and they are starting to fill. They're in slow fill right now. If you want to use NASA terms to describe what's going on. But they've definitely tanked it with GN2, which means I'm going to guess that we're going to see a start of the center engines today. You wouldn't see this here if they were going to do the outer ring engines. The reason why you wouldn't see that is because you do not need the chines, the nitrogen tanks that are inside there. You don't need those to start the outer engines. Inside of the orbital launch ring right here, this thing that looks like a giant Oreo cookie. It does look like a giant Oreo cookie. I never noticed that. Looks like a double stuffed Oreo cookie. Anyway, moving on. Inside of that is a pneumatic system, and the starter motors for the outer ring, the outer 20 ring of Raptor booster engines, or just Raptors. They're just Raptor engines nowadays. The outer ring needs the pad to start. Believe it or not, they're using they're using GSC, the starter motor, the starter mechanism. I say starter motor because car. They don't have the starter motors attached to them. They're part of the umbilicals. There's 20 umbilicals that hold SLS. Nice. There's 20 umbilicals that go around the inner ring of the Oreo cookie here, I guess. And those simultaneously hold the vehicle up, and they also have a tail service mass carrier umbilical similar to SLS, but there's 20 of them. Each one of them has a GN2 line that will lead to the starter motors, or it leads to the gas generator part of the stage combustion cycle turbopump. It's technically called the preburner. That's what starts the engines. They basically, you ever take compressed air and shoot it into a computer fan and it goes zzz, literally that. It's kind of like an APU, Blue. I don't know if APUs are pneumatically started. I mean, are they? I have no idea. If that's an Oreo, it's definitely double stuffed. Yeah, for sure. Is the liquid oxygen tank above or below on super heavy? Methane up top, liquid oxygen on the bottom. I mean, a little bit, Bandit, yeah. So the preburner is more like a jet turbine. Not a jet turbine, because jet turbine implies turbojet. It's a gas generator. But it's a closed cycle gas generator. And if it's a closed cycle gas generator, then you call it, it's a preburner. So I'm trying to think of a good way to describe this. Okay, so let's take the methane preburner on Starship. What does that look like? So we'll start at the top of the shaft. Start at the top of the preburner shaft. So at the top, there's a fluid impeller. That's the pump. That's the pump part of it, right? That fluid impeller is a radial fuel impeller. And what it does, it pulls fuel in vertically and shoots it out horizontally. So radial, i.e. perpendicular to the rotational axis of the turbopump, right? And then from there, that fuel goes into the cooling jackets on Raptor, and that preheats the fuel. And then from there, actually, hold on. I'm trying to retrace the Raptor plumbing in my head. I don't think I got it totally right. Hold on. Raptor engine diagram. So part of the fuel mixture does go into the nozzle, but oh, I did have it right. Score. Excellent. Yeah, okay. So there's your impeller right there. Liquid methane comes in. It goes through the fluid impeller. It goes radial out, just like I was saying. Radial out into a fuel valve, right? And then from there, it gets circulated through the nozzle, through the cooling channels, those copper cooling channels that Raptor burns off when it runs engine rich. Yeah, that's what those are. And then from there, right, you have a circulator that goes back and it recirculates the liquid, the warmer liquid methane into the gas generator. The gas generator has liquid oxygen injection here. Okay, so they take LOX that's tapped off from the LOX turbo pump over here. You see there's a little tap off, and that injects right through the gas generator, right? So this works like a combustor almost on a jet engine. And then from there, this gas generator combined with the turbine right here, that's the pre-burner, okay? That's the pre-burner. So from there, you get a very fuel-rich mixture going in. You get a very fuel-rich, partially burnt mixture going into the main injector pumps on Raptor, right? And then there's a methane tap-off. The gaseous methane gets preheated, exchanges heat with the preheated propellants, and that's the autogenous pressurization. And then from there, it gets combined with a oxidizer-rich mixture up here. Because on the LOX side of things, right? On the liquid oxygen side of things, you have the LOX that goes through the main impeller. And the turbo pump on this one is an axial flow turbo pump with a tap off on the side. The tap off on the side leads to a couple of different things. There's the purge line. And then there's a pre-valve to the injector plate right there. That's for, I think that one's for engine starting right there. And then there's another pre-valve right here that goes to the, methane turbo pump, right? I don't know. Somebody made a typo. And then so there is a tap. If you look, there's a methane tap off here from the heated up methane. See that right there? It goes out and it goes into a second pre-valve right there. And that pre-valve goes in to basically the second gas generator. The second gas generator here is right there. And that one takes a methane, it takes methane and it combines it and it ignites it a little bit, right? And then that shoots an oxidizer-rich mixture into Raptor. So you have a fuel-rich mixture and an oxidizer-rich mixture combining in on the main injector plate, and that's what blows up out the bottom. This is called a full-flow stage combustion cycle. If it looks complicated, it is. If it sounds complicated, yes, it absolutely. Oh yeah, it's very, very complicated. This is really, really, really hard to do. You basically have two jet engines. There are two jet engines that feed into a rocket engine. One of those jet engines is running really fuel rich. One of them is running very oxidizer rich. I'm talking about when I say fuel rich or oxidizer lean. So there's lean and rich. We're talking about the ratio of oxidizer to fuel. So with the methane turbo pump, or not a turbo pump, it's technically, you technically call it a pre-burner. The gas generator is part of the pre-burner. But if I say turbo pump, that's what I mean. I mean this. The methane turbo pump, the gas generator is part of the turbo pump, and once again, this is closed cycle because the exhaust is going into the rocket engine. That's a closed cycle turbo pump, right? Shuttle does something like this, actually. And this mixture that comes out has way more methane than oxidizer. It's partially combusted. That makes it way more, you get more energy out of it. So think about this as like a afterburning jet engine. That's feeding, and the exhaust from that afterburning jet engine is feeding into the rocket engine. What does a jet engine do? A jet engine with the afterburner on is spraying insane amounts of fuel. You're running fuel rich out the back to get more thrust, right? This is like an afterburning jet engine spraying into a rocket engine. Simultaneously, this side of it is like an afterburning jet engine that's running lean. It has way more oxidizer in it. And that oxidizer lean and fuel rich go in and they blow up in there. How many engines in the static fire? I'm not sure. That's weird, Bandit. Can you make it car talk? Why have a preburner? Why not just pump the fuel and oxidizer together? So Geek, usually, okay, Goalie and Geek, I'll tell you in car terms. So usually preheating your intake air is bad, right? You're going to get, it's not going to be, you ideally want cold air going into an engine, right? Cold air intakes, right? Or if you have a turbocharger on your car, you want an intercooler, or a supercharger, you want an intercooler, right? Why? If it's colder, you know, the molecules contract and you can get more oxidizer into your car. More oxidizer you get into your car, more fuel you can deliver, right? This is on a car now. Then you make more power that way. So you generally don't want to preheat your intake air, right? That's not good. If you're heating up the intake air going in, that's less molecules that are going in. You're going to have worse flow rates, right? So now let's think about this for a second. So think about, okay, so say you have cold air, you have super cold air going into your car, right? That piston comes back up. What does that do to the air-fuel mixture? Seriously, think about it. It's going to heat it up because you're compressing it. Anytime you compress a gas, even if it's atomized air and fuel, it's going to heat up. Right? So, and the more you can compress that gas, right? Excuse me. The more you can compress that gas, the bigger, the more energetic the explosion you're going to get, right? But you're heating it up now. Preheating your intake air is fine as long as it's done post compression. In fact, if you heat it post compression, you're going to get way better you're basically going to get way better atomization. So what's atomization? Atomization is how efficiently, basically, in terms of combustion, how efficiently something combines, like how efficiently your fuel and oxidizer combine. And if they can combine better, it's going to be more efficient that way, right? You're going to be more efficient. You get better atomization, you're improving efficiency. So, Geek, what they have with Raptor here, right? This is getting you insanely good atomization, right? The exhaust from this is you're getting really good atomization, right? Because you're compressing everything, right? And then you're heating it so it can expand, and then you're combining it with oxidizer. You get really good atomization, right? But you also get extremely hot flow coming through the main kind of power head right here. So that gives you, this is all spread out, right? It's all spread out comparatively to here because, one, you went from liquid to gas, so your pressure is going to drop somewhat, right? Turbopump outlets actually have the highest pressure in this whole system. Right there is the highest point of pressure, right? So the pressure is gonna go down, but it goes down basically post compression, right? So you get an extremely hot expanded mixture going in here. They basically blow it out. They combine it with some oxidizer to basically preheat the fuel. They preheat the methane, and that makes the methane spread out. They do the same thing with the oxidizer. That makes it all spread out. So when they shoot it through the injector plate, you get insanely good atomization, right? And that improves efficiency and actually makes this thing, Raptor has an insanely high chamber pressure because of this. You're preheating your oxidizer and fuel basically this way. That's the best way I can describe it. It's a little more complicated than that, but that's layman's terms. Yeah, it's much easier to atomize gas with gas, bingo, than liquid with gas. It's way easier to atomize this, and you're delivering it at a pretty damn low pressure for trying to deliver that much air and fuel all at once, or oxidizer and fuel. Yeah, you're getting way better efficiency because you get insanely good atomization. This is why Raptor is like pushing the theoretical maximum of like a specific impulse from methane. It's extracting every bit of freaking energy out of that methane as you possibly can. That's why Raptor's flames are so ridiculously clear, despite having some carbon emissions, right? Compare that to like a Carolox engine where you just literally roll coal out the bottom, right, Geek? Right? Like that's really that's really not as efficient, but it's extremely energetic. This is getting the best of both worlds. You're getting all the energy out of this thing, but you're also doing it very efficiently. It's very much min-maxing Methalox propellant, but yeah, full flow stage combustion like this gets you great atomization. So here, you want some trivia here. Who needs good atomization? Just increase L. Yeah, I know, Lavi. There you go. So, a little bit of trivia here, right? So, let's think about the shuttle engine. What do you think would favor the shuttle engine, especially with what we know about Lavi? Don't answer this. What would the shuttle engine use, especially since what we know from hydrogen with all the flow is the shuttle engine running an oxidizer-rich stage combustion? Is it running fuel-rich stage combustion, or is it open cycle? You tell me. It's one of those three. Which one would be favorable, especially with what we know about hydrogen and what it does when it gets turned into a gas? Think about it. Seriously, noodle on it. Gotcha, I don't understand at all what you're saying, but I get it. Geek, I can go simpler if you want. The shuttle engine's open cycle? No. W, if it was open cycle, you'd get delta 4, right? If it was open cycle, you'd get delta 4. You'd get a big hydrogen fireball coming out the bottom because our 68s are open cycle. They're literally shooting, they shoot gaseous hydrogen out the bottom. And when delta 4 ignites, you see that big orange fireball because they're purging off all the hydrogen. Oxidizer rich? It wouldn't be oxidizer rich because if you're running oxidizer rich, that hydrogen is really small. You'd end up leaning out the engine and wrecking it. Space shuttles run a fuel-rich stage combustion cycle because it's hydrogen, right? So what NASA does with the shuttle engine is they have a low-pressure fuel turbo pump, right? And that low-pressure fuel turbo pump feeds into the nozzle on the shuttle engines. They flow the hydrogen through the nozzle, and that gets the hydrogen to heat up. That makes it turn into a gas, right? It gets gaseous, right? And then they combine it with a little bit of oxidizer, and they expand that hydrogen as much as possible in the high pressure fuel turbo pump. The HTPFP is what it's called, high pressure fuel turbo pump. They basically expand that hydrogen as much as humanly possible because the more you expand it post compression, so after the turbo pump, the more you can spray more oxygen in there, right? And all that oxygen will combine with all that hydrogen as long as the hydrogen is spread further apart. It's called atomization. The better atomization you can get, it doesn't matter if it's a car engine, it doesn't matter if it's a rocket engine, it doesn't matter if it's a diesel engine, it does not matter. The more atomization you can get, the more efficiency you get, because that means more oxygen is combining more with the fuel. Or in the case of the shuttle engine, every single bit of LOX that they put in that dang thing is combining with hydrogen because they basically spread the hydrogen out big time. And then they spray liquid oxygen right into that big spread out field of hydrogen, and that's what you see coming out the bottom. The space shuttle engine's flames are clear. They are clear. You can see right through them, like as clear as a pane of glass. The reason why is because it's extraordinarily efficient. You're going to get insane efficiency out of this engine, out of shuttle engines. You're going to get ridiculous efficiency. They make 420. Nice. I think it's like, I don't know. It's above 400. I forget what it is off the top of my head. It's way up there, like 430-second specific impulse, which, guys, like, with the shuttle engines, if we're talking about it in, like, car, if you want to attribute it to cars again, We're talking about an engine that makes 1,000 horsepower, right? That gets 100 miles to the gallon. That's what we're talking about here. Because with rockets, you can have your cake and eat it too like that. You can find ways to do it, especially if you're using hydrogen. 33 engine spinny? Let me take a look.
There's a spin prime indicators that we see here.
452 seconds. Yep.
There's a spin prime test.
Oh, that's cool. Oh, look, they gas purged it. Did you see it? Lava, you see it? They gas purged it. Watch. They spin it up, and then you see a secondary puff
We'll point
come
out
out
any
the
other
bottom.
indicators that we see here. There's a spin prime test.
Right there. See it? They purged it out with nitrogen. Interesting. And then
it's still a spin prime test. I think it's...
They're hitting it with nitrogen there. They're hitting with nitrogen to make sure it doesn't pop like it did before. You want to put inert gas in there. Or just it's a really awesome smoke machine and SpaceX is about to have a rave, which I wouldn't throw it past. I wouldn't throw it past them. But yeah, the better atomization you can get, the more efficiency you can get. And if you take something like Hydrogen Geek and you atomize, you could spread hydrogen out so it atomizes better, you're going to get insane efficiency and insane power. That's what made the shuttle engine so ridiculously good. Dude, shuttle engines are good. They're great engines by today's standards. They came about in the mid 70s. They were light years ahead of anything that anybody else ever had. Yeah, they still are. The only thing that even comes close is Raptor. And I think Raptor might surpass the shuttle engines in terms of ridiculousness because since they're using methane and you have that carbon in there, you have CH4 instead of just H2. You know, to get better atomization, you really got to heat it up. That carbon can take a lot of heat, so you really need to heat the thing up. So a full flow combustion cycle is probably better for atomization, even though that might be the case. It's a more complicated molecule that you really have to spread it apart. So they probably have a more insane preheat. I'll bet you the exhaust from the gas generator on Raptor is way hotter than it is with the shuttle. That's just a guess though. Yeah. Now, I have another question. If you're going to use hydrogen, right? If you're going to run a fuel-rich stage combustion with hydrogen, and Raptor is using methane, which is kind of in the center, right? And that's a full-flow stage combustion to get you the best balance of efficiency and power. What would you use with Carolox? Would you use fuel-rich stage combustion or oxidizer-rich stage combustion? Oxidizer-rich gameable? Expander with supercritical kerosene. Enjoy the nightmares. Are we just complicating things to complicate them, Lavi, or... I, too, like making extremely complicated engines for not a lot of gain. Oxidizer rich, LOX rich. Why would you run oxidizer rich with kerosene? Why would you do that? We got a booster depress there. There you go, Bobber. Hotter. Burn as much kerosene as possible. What do we know about using kerosene? What comes out of the bottom of a Merlin engine as opposed to the shuttle engine? The shuttle engine burns so efficiently, the flames are clear. You can see right through them, right? What about a Merlin 1D? What comes out of that? Oh, a nice big carbon sooty mix of fun, right? I will in a second, Forge. Nice big sooty mix of carbon. So, Carolox engines are extremely inefficient compared to their hydrogen counterparts, right? It's extremely inefficient. Now, if it's so inefficient, why do people use them? Well, people use them because you get the most energy out of them. you're going to get an extremely efficient burn. Why? Because you throw an insane amount of fuel at the problem, and the fuel combines with as much oxidizer as you spray, and you end up running fuel rich out the bottom. They basically spray charcoal out the bottom of these engines. Now, don't get me wrong, I get a carbon emission, and people say, oh, it's bad for the environment. And it's not as bad as you might think. It's not. Rockets are a drop in the bucket, so don't even try that. It's not even worth it to try and make that. We're talking about engines now, right? So if you were running oxygen rich, right, and you spread that oxidizer out by preheating it, right, through a preburner, you spread the oxidizer out as much as you possibly can, and then you spray fuel into that spread out oxidizer, and you're running fuel rich already, right? More of that fuel is going to combine with more oxidizer. You're going to get way better, once again, you're going to get way better atomization, but it's a little bit different, right? The reason why it's a little bit different is because you're running liquid oxygen and you're running kerosene. Kerosene is not a cryogenic propellant. You could just fill it up with gas, like it's like diesel fuel. So it's liquid at room temperature. You take that liquid oxygen, you give it a little bit of heat, it spreads out like crazy, combines with as much kerosene as humanly possible, right? And you're going to get way better efficiency and make way more power. And you still run a little bit fuel rich, but your efficiency goes through the roof because you're atomizing the oxidizer instead of the fuel, because you can't atomize the fuel because it's kerosene. It's really hard to do that. It would be really hard to atomize a non-cryogenic propellant. The cryogenic propellants are really easy to make the spread out, because all you need to do is just heat it up a little bit before the liquid turns to gas and it spreads out like crazy, right? Same thing with SLS. SLS has those leaks because even hydrogen moving a couple of degrees warmer will turn to gas and it'll go everywhere. And NASA's worried about it atomizing with something that they don't want it to atomize with and causing an explosion outside of the vehicle, right? Little bit on physics and chemistry there. Does the RS-25 run liquid oxygen rich? Well, D-Man, I just explained that a second ago. How much do Methalox engines leave? Depends. Atomizing the liquid oxygen, guys, improves thrust. Atomizing the fuel improves efficiency. See what I'm talking about? If you atomize both of them, you get the best of both worlds, and that's what Raptor's doing. Suborbital pad is alive, venting, here we go. But why male engines? Are you serious? I just told you that a moment ago. Kerosene requires a lot of O2 to completely burn. Also, somewhere north of 50 times molar than LH2. Yeah, SWK, I mean, you're trading energy for efficiency. You want more energy or do you want more efficiency? You can try to have both of those things, right? But that gets complicated really fast. Enter the Raptor engine, right? That would get complicated very quickly. So how did S1C compared to Falcon 9 for burning? Burning? Okay. So how did you're talking about the F1 engines? The F1 engines ran about as fuel rich as you can make any rocket engine run, goalie. Now, there's trade-offs, right? Rocket engines do run fuel rich. Raptor still runs a little bit on the fuel rich side for temperature purposes. The Merlin engine runs extremely fuel rich. See, that's the benefit of just using an open cycle gas generator engine like a Merlin 1D. You're running extremely fuel rich, and that keeps the temperature down, just like in a car. Same thing. Atomization creates heat. It creates a lot of heat. Yeah. Well, no, not necessarily atomization. Atomization gets you cold. But, you get a more energetic reaction, right? It's going to generate a lot more heat. And if you're atomizing your oxidizer, if you're spreading out the oxidizer so it can make a screen that combines with more fuel, you're going to make more energy, and it's also going to be more efficient, so you're going to generate way more heat. So what a lot of rocket engines do is they run extremely fuel rich. They basically flood the rocket engine and run on the way fuel rich side so they don't melt the thing on the outside. Save the Earth, let's use electric rocket engines. Farm, I see you're into fairy tales. Does that make sense, fellas? You see what I mean? It's all about spreading the stuff out so you get better atomization. I can show you what atomization looks like visually if you really want to. It's an excerpt from a really awesome YouTube video from a great YouTuber, Destin, over at Smarter Every Day. So I don't want to watch the whole thing because, you know, trust me, go over to Destin's YouTube channel. You want to learn about this kind of stuff. He has an awesome video about showing what atomization looks like. I'm just going to show a quick clip of it. Okay, so here it is. So with an engine, right? Once again, this is right off Smarter Every Day. With a car engine, or particularly a carburetor, it uses vacuum. So that piston is going up and down. So if this is the choke point, right? This is what's called a venturi. Right here, it's basically an hourglass, and it's designed to create low pressure. You get air sucked in here, and it's sucked in at really high pressure right here, and then it depressurizes in here. And that especially happens with a piston going up and down, right? Think about the volume that's beyond this, that's down there, right? When both the valves are closed on a four-stroke piston engine, right? You have a certain amount of volume this way. And then the intake valve opens and the piston goes down. You're drastically increasing volume right here, and because there's a choke point, the pressure drops like crazy. And that fuel gets pulled in with the vacuum, and it hits that low pressure air, and it atomizes. Watch. Ready? Wait for it. See it spread out? See what I mean? Spread out all over the place. That's atomization right there. Rocket engines do this. Car engines do this. Anything that combusts anything does that. Yeah, Ordon. Destin's amazing. And I only want to show like a quick clip of it, but that's the pay dirt right there. See the atomization? Because the piston's going up and down and you're getting a pressure drop. Right? That's what car engines do. They make the vroom vroom noise. See? What? See, it's creating a vacuum in there. The fuel gets put into a low pressure environment. Now you're kind of at 1 bar in here, right? And then the intake valve opens, the piston goes down, it pulls in that air, but there's a choke point, so the pressure drops. See? That's what I mean about spreading out the liquid oxygen, or spreading out the liquid methane, or spreading out the liquid hydrogen, or spreading out both of them, methane and oxidizer. Raptor does that, blows it up, and then takes that and puts it into a rocket engine. You're getting insane atomization with Raptor. Like, it's the most efficient that you can possibly get, and you're going to make way more power. So how does a rocket do that without a piston? It's a good question. That's a really good question, actually. Well, that's one of life's little secrets there. How would you do that? How do you make that work? You need a choke point somewhere. You're going to need a choke point somewhere. Where's the choke point? There is a choke point in this design, similar to a Venturi. Where is it? There's one. No, don't go there. That's not it. It's not that. It's not that. Where's the choke point? The throat? Well, the throat is a Venturi in itself. That's all a rocket engine is. It's just a Venturi. It's called a convergent-divergent design. A rocket engine is just a Venturi. You're taking extremely high pressure, you're choking it off, and then you're expanding it. So it makes an insane amount of thrust. Middle of the engine bell. Well, that's the throat. Remember, we're talking about atomization here. This is pre-combustion, so it's before the explodey part that happens right here. It's not in the chamber, but it kind of is. It's the injector plate. This thing right here. An injector plate. So SSME injector plate. That's how they do it with rocket engines. That's a Saturn V's injector plate right there. That's an F1 engine's injector plate. See the two dots? Two of these dots. Guess what those are? They're little tiny Venturis. Just like a pintle injector on a fuel injector. Solenoid driven pintle injector. That's what a fuel injector is on a car. They're right next to each other. But because a fuel injector on a car is solenoid actuated, it's going on and off because the piston's going up and down, right? With a rocket engine, you can't rely on the piston being able to make vacuum for you. So you have to make a choke point before your combustion chamber. And your combustion chamber has theoretically infinite volume, right? Because that fuel, it's just going to get shot out the bottom. It's not theoretically infinite. That's not the right way to say that. But long story short, you can't wait for the piston to come back up and decompress. They have to figure out a way to do it all at once. So they pressure feed an injector plate. The fuels the fuel or oxidizer fuel mixture or whatever, your fuel and your oxidizer on the backside of the injector plate are at extremely high pressure, and then they get pinched through these choke points. They atomize, they blow up, and they go out the bottom. It's the injector plate. The injector plate is the choke point in every rocket design. Now, you want to noodle on something crazy? Listen to this. How the heck do you get atomization? How do you get atomization in a rocket engine? Think about it for a second. How do you get atomization like that? Rocket engines tend to be a little bit high pressure inside of the combustion chamber. It's just something to kind of think about. That's one of the things when they always say, oh, spaceflight is really difficult. Well, yeah, that's it. You need to go from extremely high pressure to extremely low pressure to combustion, or to atomization to combustion to extremely high pressure again. How do you do that? How do you do that in a system that's completely open? There's no pistons, there's no valves when a rocket engine is on, right? This is hard stuff, man. This is really difficult to do. Hey, Greg, thanks for the raid, dude. I appreciate it. Yeah, Demondred, a shower head kind of is, it's kind of the same idea. Now, don't get me wrong, don't go taking your parents' shower head and trying to make an injector plate with it. It's not going to work. It's designed for water, not rocket fuel. Don't do that. But it is the same idea. Next time you're taking a shower, look at the shower head. It does something like that, especially if you set it to the Mister setting. You know, mine has a little adjuster thing. Now, I don't know about you. I set mine to the Mister setting because it reminds me of an injector plate, and that makes me happy. Yeah, I'm not weird, I swear. Perhaps a garden hose would be more apt. I mean, what is a shower but a garden hose that's inside your house, drummer? What's the difference? It's my shower head, not my parents'. Okay, don't go taking your shower head and doing that. Pretty crazy, huh? Yeah, see? Check it out. Fuel and oxidizer. They spray right next to each other. They choke them off inside of the injector plate, and these two holes are right next to each other. And see, that's an axial flow injector plate. Now, you can get, the crazy thing is that you can have fuel delivery systems with a rocket engine that are radial flow. Axial flow meaning the rocket engine's pointed that way, and you're delivering your fuel on the same axis that the rocket engine is pointing. That's an axial flow injector plate. There's radial flow injectors too. Seriously. In fact, a radial flow injection system, or a pintle injector is what it's called, is part of the reason why Falcon 9 can land. Because with an axial flow injector plate, you can get cavitation inside of your combustion chamber, which is exactly what happened with the Saturn V F1 engines. That's why the pogo oscillation on Apollo 4 and Apollo 6 and Apollo 13. The pogo oscillation came from the radial injector plate, and it made it to the point where they had to put baffles to get the propellants to go in the right direction, the atomized propellants to go in the right direction, or else you get cavitation temporarily inside of the combustion chamber, and that causes a temporary moment loss of thrust. And that varying thrust between the 5 F1 engines were causing the Saturn V to pogo up and down like this on the way up. Think about it like if you did it in KSP, launching the rocket and hitting ZX, 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 ZX as fast as you can. What does the rocket do? It's going to go, right? Pretty cool, right? Anyway. Our queen here in the UK has just passed away. Ah, that's a shame. I mean, human, you keep saying that and you keep trying to correct me, and I keep telling you that you're wrong. And people that work on rocket engines also say that you're wrong. But, I mean, sure, keep doing your thing, man. Like, dude, it's called cavitation. I'm sorry. Like, I don't know. It's possible that rocket science could have a different definition for the same word. So would the bigger pumps have helped? Goalie, the F1 is theoretical maximum, dude. You can't make a Karolox engine bigger than that thing. Ask the Russians. They tried. Rip to Queen Elizabeth. That sucks. But hey, you know what? I always say this. Fellas that are over there, if this means something to you, I always say this. You know, I don't mind when people pass away when they're old. That's fine. That's okay. They lived a long and healthy life. That's perfectly okay with me. People get old. They die. You can't beat Father Time, right? Can't do it. You know, and I'd say the Queen has done a lot of good things. You know what I'm saying? A lot of good things. Because if I made a, oh no, anyway joke, you guys would probably get a little mad, right? Probably get a little mad. But also top gear jokes. Kind of funny. But also, my condolences. She got up there. She got up there. Hey, Tessa, sometimes the mileage just gets too high, man. Sometimes, I mean, dude, this is a system, just like an automobile. Yep, here's the car analogy. Boom! Didn't expect that from me, Jay, did you? No, stuff wears out, dude. Stuff wears out. Eventually, it just quits. You know, it's like a Toyota Hilux engine. You'll beat the trash out of it. You'll drop it from a building. If sometimes it'll eventually just quit. Sometimes it's just you just hit the end of your mileage. You know what I'm saying? No, Simula, I never played Eve. Yeah. I don't play Eve out of fear of addiction. But yeah, hey, guys, that sucks. My condolences to you guys. That it sucks. That's not fun. You know what I mean? It's like when we lose a president over here. It sucks. It's not fun. Are you comparing the Queen to a Toyota Hilux? Yeah, because the Queen was awesome and she lasted an extremely long time. How can you not make the comparison? Elon talked a lot about cavitation causing erosion in the pumps. Yeah, human, you don't want your oxidizer to turning into gas. The only time you want your oxidizer turning into gas is in a pre-burner or in the rocket engine. It needs to stay in liquid form through the plumbing, or else it's going to start rusting things really quickly. And then you play F1 Manager. Stimuli, 13-month resub. So, you know, for everybody that's in the Commonwealth, that sucks, you guys. My condolences from over here for what it's worth. She didn't quite make it to the record for longest reigning monarch though, which would have been cool. Yeah. That's like you said, when it's like I was saying, you know, likes. Yeah, and I know this doesn't. I mean, that would have been cool, right? But dude, the human body can only do so much. You know what I mean? You're gonna get to a point, and where it's just gonna be like, nah, I don't want to do this no more. You know? It's just like I said, it's just like any other mechanical component or any other and like system, you know, it's just system has its breaking point. Every system does. Completely off topic, distracted but worth a chuckle. Winner of today's Darwin Award. Some guy had his Jeep stolen because he left it running when he was buying coffee at a gas station. So he thought it would be a good idea to say his 6-month-old kid was in it so the cops would be all over finding it. They've been going nuts all morning and looking, and they found the Jeep with no kid. His mom saw the news and called, and it turns out the kid was with her the whole time. Well, you got your Jeep back at least. Off-topic question. Does that F1 2022 game have accessibility options for deaf, hard of hearing, and or color blindness? I'm not sure, Hokey. I'm not sure about the accessibility. I can't speak to it. Some people really like their Jeep. Yeah, Franco, it's a Jeep thing. You wouldn't understand. Yeah, the police probably got a little pissed off about that. Yeah, I don't think that's really a Darwin Award. That's just, I mean, good for that guy for thinking on his feet, but also, I mean, you did get your Jeep back, but at what cost? You know what I'm saying? Are you in the position to be able to live stream launches, like going down to Florida? Simulate, I can, but I have all the equipment to do it except for the live view. I was, for Route 154, when I did live streaming and driving across the country, I was borrowing some of NASA Spaceflight's equipment and DAS's equipment. So I'm on my way of getting set up on my own. And when I do, you might be able to cover it. The problem, so there's a thing. And Das and I ran into this, more Das than anything, because he's the one that was going down there most of the time. I say, I was part of it. It's more Das. Das ran into problems in 2016, 2017 with covering launches like that. The reason why he ran into problems is because if you're live streaming off a remote, i.e. not on a hardwired connection, when the rocket launch, everybody turns on their phone, everybody takes pictures, everybody posts stuff to Instagram, you know, selfie, hey, look at me with my rocket launch, you know, like, which is fine. I get it. That's cool that people are excited, but it tanks the cell signal. Like, tanks the cell signal. Very bad. And it's only gotten worse with, you know, as there are more spaceflight fans. So nowadays, you know, if you're going to do remote streaming, it's better to get a press pass and hardwire your connection. But, yeah, I mean, ask anybody that works in, like networking like that. It is, yeah, the bandwidth goes to nothing. Like, nothing. An hour before the launch. Yeah, everybody's got to be on Facebook, you know, like, hey, I'm covering the rocket launch here. Oh, wow, look at it launch. And don't get me wrong, that's fine. I'm happy that people are into it. That's really why I do this. But also, it makes covering launches on location prohibitively difficult. I'm aware watching the NASA stream for the updates was not fun. I've never really watched nor follow F1, nor really understand it. How accessible and noob-friendly is F1 Manager to somebody new to the franchise? There is a help system, Vanguard, but you probably want to watch the races and learn and understand the subtleties to it, or else you're going to fail miserably. But if that's your thing, then yeah, go and fail and understood why you fail and get better. Yeah, Perky, no one cares about Starlink launches anymore, which is kind of funny. There's actually 2 on Sunday. Actually, one's on Saturday, another's on Sunday. About the FOD question I asked yesterday. Yeah, Forge, I was here before you got here. I was here at 11 my time, so an hour before my usual start time, and I covered the press conference. There's an enclosure because they're changing the seal. You'll be able to see the entry burn from your house. Nobody cares for the trees anymore. But yeah, hopefully you guys learned something about rocket injectors. It's really interesting stuff. I personally, I mean, if you even have a remote understanding of what a rocket engine is doing when it turns on, like, you get a certain kind of respect for the people that do this kind of stuff. You know what I mean? It's like, wow. You made it do that? Oh. Okay. I love Starlink launches. You should try to get an interview on Starbase with Elon. I'm not sure I'm popular enough to be able to do that. Wait, I keep calling you Simuli. It's Simule. Simule? Did you change your name from Simuli? I'm confused. You'd make a good chemical engineer at MIT and, of course, NASA. At MIT, David? I mean, MIT is just up the street from... Well, I can't say that anymore. I moved out of Boston. I still live in Massachusetts, though. MIT is a little ways away, but yeah. If you know anybody over there, could you put in a good word for me? I'd love to go talk with those guys. I don't know what about, but it would be fun. Like... If I get an audience with somebody, I can certainly demonstrate that I understand the source material. The problem is getting an audience with people. You know what I mean? That's what I mean about not being popular enough for it. I'm fairly confident that if I went to space, I'd be like, yo, I want to talk to Elon. They'd be like, yo, no. You know what I mean? Maybe not MIT, but WPI might like a word. You know anybody there, Orion? Just show up and knock on the door? How's this for a picture? Yeah, I don't hate what's going on in that picture. Yeah. Or we could just go Goodwill Hunting, and then I'll just get a job being a janitor there. You know, just do the Goodwill Hunting approach. Walking through MIT campus, you can say you've been to MIT, right? Yeah, I mean, I've been on the campus plenty of times, Stealthy. Actually, fellas, I won't say how or where, but I might actually have an inn over there. Not that it matters for you guys, but like I might have an inn, and I might be able to get an audience with people. Now, don't get me wrong, like I don't think they're gonna be like, well, you're smart enough, you need to go to school here. I don't think that that's gonna happen. But having it turns out that the aerospace engineering department at MIT has a lot of people that know a lot of people. So the connections might be worth it. Now, how do you like... People know people. Noted. Yeah, Peepo G. There's your EJ top tip for the day. I don't like the sound of them apples, Will. What are we gonna do? Jackie? Yeah? It's hunting season. Applesauce, fool. Tips? Huh? What? I wish that worked like that. Yeah, Newt, that would be really good. Right? Like, where's Das these days? Das is doing production. He's the lead producer for NASA spaceflight. All this infrastructure, all the live streaming at McGregor, live streaming here, the fleet cam at Port Canaveral. Yeah, that's all him. Yeah, he does all the back end for that stuff. Yeah, that's what he's been up to. Unfortunately, and this is Das's words, not mine. Unfortunately, that really doesn't, maintaining a live 24-hour live stream from 2 locations in Texas and 1 location in Florida takes up a lot of time. So doesn't have much time to stream anymore. But yeah, guys, I might have an inn over at MIT. But yeah, once again, David, if you know somebody, please, I'd love to get an audience there. That would be pretty sweet. Well, Mew, I think the Nightbot link thing is working correctly. Okay, it's 2 o'clock, guys. We gonna get into some Formula One or what? Will you ever host on NSF? If they wanted me to, Acid, sure, I'd do it. Yeah, I mean, if they wanted to. You hear the news about the Queen? About 1,000 times already, Elon. Yeah, shame. What can you do, man? She's old. I think she made her mark. We're good, you know? Does NSF know you're available? I'm pretty sure. Yeah. Will we see a Haas win tonight? You need to come to Phoenix. ASU Lunar Reconnaissance Orbiter Control Room is really cool. Neat. F1 time. Also, thanks for making Gary a millionaire. Yeah. Yeah. Flight sim, you know, that's how I run things. Like, if I was running a business, this is how I'd run. I firmly believe in, you know, giving your employees a raise like that is putting equity in them. Now, don't get me wrong. You don't give people a raise that don't deserve it, right? But, you know, if someone's doing a good job and you want to ensure that they're going to stay with you and not find another job, you give them the money that you think they deserve. And that's equity in your employees. Then you grow the team and the team gets stronger that way because, I mean, honestly, if I gave Gary a 5-year contract, you know, you give him a 5-year contract, he doesn't need to worry about that for the next 3 to 4 years, right? Doesn't need to worry about it. No distractions. That's what I mean. Equity in your employees. I firmly believe in working with the group that you have. You know what I mean? It takes a long time to build up that teamwork, to build up the teamwork. And this is true for spaceflight as well. It takes a long time to build the team. You know, and I know every corporate entity nowadays throws around team building exercises. That's not what I'm talking about. And, you know, the team building exercises are a way that they think is going to work, but it actually doesn't really do anything. Yeah, Yoda, I've heard. Did you see the Dream Chaser announcing point to point? No. Link me and I'll cover it for Space News, Stealthy. Are you training a driver to replace Magnussen or Schumacher? I have Logan Sargent as my reserve driver, yeah. As a corporate worker, we have no real team aspect. Yeah, Newton, that's part of the reason why I think corporate culture is at odds with the human condition, but that's okay. The aerospace in the United States Department